So this is the day number 1 of the 2026 revision class and the periodic variations tut. You will get this, don't worry. Once you make payments after today's class, I will be couriering the tuts. Okay. Now, first of all, welcome. Welcome, and this is the first class. I need to tell you certain things. First one, forget everything that is in your head right now. No matter what your past is, doesn't matter. You can change it from today. I won't take much time for like motivation and all this time in 2026 revision class because we have a limited amount of time, 8 months, and actually we need to have 2 classes per week, each class around 3 to 4 hours, and also a midnight accelerator may එකක් තියන්න ඕනේ around 1 hour to do something extra and to revise and to have a friendly chat with all of the students. එක තියෙන රැට like once you finish all your day's work at night, probably around 10 p.m. you can join this meeting and like have some fun and also learn and then leave the meeting and sleep well after that. So ඒ වගේ session එකක් I'm going to start probably next week or this week, probably on the weekends. හරිද? Right. Please turn off your cameras and the mics. Hurry. Okay. People, quantum numbers. Now, what are quantum numbers? Memai. You guys have addresses at home, right? You gave me certain addresses, people who made payments. This is my address. This is my address. When it comes to atoms, people, they also have addresses. Each electron in an atom is specific and not equal to one another. Their locations are different, and those locations we have to name it. That is what is an address. This is my location. To be specific, I need to tell my room also, like which room I am staying, which room I am sleeping. This is the address of a normal Sri Lankan human. When it comes to an atom, the address will look something like this. Nikang mehema. 200 plus half. Those who don't know anything about quantum numbers will be like, what is this? What does each of these letters mean? මේකේ හැම letter එකක්ම මේ letter එකක් නෙවෙයි number එකක්. Each number, what does it mean? That's a problem. You guys know what is this? You guys know what is this, but you don't know what is this. This is an address of an electron. People, if you want to send a letter to an electron, you have to know its address. Today, we are going to send letters to electrons of every atom in the periodic table, and you need to know the location of each and every atom in the periodic table. Hare. Etakota, what is this first one? What is this second one? What is this third one? And what is this fourth one? We are going to learn it that way. What is it? And what is this? And what is this? And what is this? People, did you understand? Quantum numbers can මොනවද? The address of electrons. Listen to me closely. You have to have an A4 sheet or something. Write the topic quantum numbers. You're going to prepare your own short note. Quantum numbers, everything is written there. All the important points are written there. There's nothing to fill in the quantum numbers part. Page number. Page number page number page number very well. I'll put the page numbers now. I can edit your tunes. I didn't send it yet. Right. So the quantum numbers part part read that part at the beginning. Atomic orbitals. Orbitals? What are orbitals? Represent the probability of finding an electron. People, this address doesn't tell an exact location of the electron. This address only tells the probability of finding the electron in that place. It's like this. People, your address, your home address, I drew it. How did I drew it? Now I wrote it. I wrote my address, okay? Now that address doesn't tell where I am exactly. I could be in the kitchen, I could be in the bathroom, I can be in my room, I can be in the living room, dining room, whatever it is, that address doesn't tell it. So what is it? That address is the highest probability of finding me. That address is the highest probability of finding me. I could be somewhere, anywhere in there. And electrons also have some probability inside an atom. If this is the atom, the quantum number says, okay, the electron is exactly here. But not exact location, we can't tell it, but somewhere around here. That is what a quantum number means. I hope you understood the concept. Now I'm going to go and look at this first number. People, the first number, before learning the first number, I want you to remember O levels. You probably did O levels, ordinary level examination. ඒක science කියලා subject එකක්. You had science නේ. In that science, you learned something like this. If you take sodium, there were how many protons? There were 11 protons inside. There were 11 protons inside, and there were energy levels. There is the first energy level with 2 electrons, the second energy level with 8 electrons. And the last energy level containing 1 electron. This is the, what do you call? The O-level model of an atom. How is the O-level model of an atom? Okay. Now people, listen to me. When you count the number of energy levels, you will get a value. දැන් බලන්න මේ electron එක. මේ electron එක තියෙන්නේ which energy level? First energy level, we call it n equals 1. What do you call it? What is n? n කියන්නේ මොකද්ද? Well, n කියන්නේ the principal quantum number. This is called the principal quantum number. Principal quantum number, and we represent it by the letter simple n. Letter simple n. People, this electron is in the 1, 2, 3. n equals 3 energy level. This electron is in the n equals 1 energy level. This electron is in the n equals 2 energy level. And now we know the first letter. First letter and first number. What is this number? Where is this electron? In the second energy level. This electron is in the second energy level. You know that now. So you call it the principal quantum number n. What's next? This 0. What is this 0? People, now we have to move into A levels. Then O levels විදිහට you have only this one. Then මේක විතරයි තියෙන්නේ. n equals 1 එකේ 2 එකේ 3 එකේ 4 එකේ likewise only. When it comes to A levels, people, inside this principal energy level, you have sub energy levels. What do you have? Sub energy levels. The principal energy level is there. And within that, you have sub-energy levels. Just because an electron is in the second energy level doesn't mean it's exactly going in one path. There are more than 3, sometimes 4, sometimes 2, sometimes maybe only 1. No, you didn't understand. Still didn't understand. There's a principal energy level. Inside this principal energy level, there are sub-energy levels. Then හිතන්නකෝ, let's say n equals 3. n equals 3 energy level, people, there are sub-energy levels. How are you going to find how many sub-energy levels are there? Now that's the issue. Now, like, how are you going to find? ඒකට තියෙනවා පොඩි equation. There's a small equation. It's not hard. Trust me, it's not hard. There's a small equation. The equation I'll tell. People, may first of all, we name this as n. මේකට අපි කියනවා L කියලා. හරිද? ඒක මතක තියාගන්න බලන්න. This is n and this is L. මේකට මම කියනවා azimuthal quantum number. Don't worry about the fancy names. People try to understand the concept. Azimuthal quantum number. You know, this is science. We try to be, like posh. We try to put names which others can't read. If you tell a normal Sri Lankan person azimuthal quantum number, he will be like fainted. And we are using these kind of words. This is simple L. L can be found by counting from 0 to n minus 1. 0 to n minus 1. Again, specific energy levels will have sub-energy levels equal to 0 to n minus 1. Again, for example, let's say n equals 1 energy level. People, n equals 1 energy level, the L values for it will be 0. 0. And what is n minus 1 now? It is also 0. So there's only 0. Again, there's only one sub-energy level. There's only one sub-energy level. Keep in touch. Now n equals 2. What do you suggest? 0 and 1. There are two sub-energy levels. Okay, there are two sub-energy levels. N equals 3, you guys tell me. N equals 3, what are the sub-energy levels according to this equation? What can you have? Tell me in the chat. 0, 1, and 2. Very good. 0, 1, and 2. N equals 4. Very good. Now you get the idea. There you go. People, this is a little bit hard concept to understand by a student. Again, if someone didn't teach this properly, you will never understand this. It'll just be a memorization. Again, try to focus and listen today, and it'll remember in your head forever. Trust me, you will remember this forever if you listen and focus today. It's an easy concept. It's not hard, but the way other people are teaching it makes it hard. The subject isn't hard if someone teaches it well. That's what I have witnessed during my A-levels back then. People, n equals 4, 0, 1, 2, and 3. Now comes the magic. People, these sub-energy levels, this 0, this 0, this 0, this 0. You give it one name. You're going to give it one name. What is the name you're going to give it? 0, not L equals 0 now. If L equals 0, then you call S. No, not S orbital. S orbital kiyanne. If some of you think that it is S orbital, you're wrong. Forget it. S sub-energy level. What is it? S sub-energy level. Inside the sub-energy level, there can be orbitals. That's a different story. But this one, you call it S sub-energy level. Some students, like, they mix up that thing also. S sub-energy level. Okay. Then 1 kiyanne mokadda? 1 kiyanne people, L equals 1 means T sub-energy level. T sub-energy level. L equals 2 kiyanne mokadda? D sub-energy level. And L equals 3 means, what is it? F sub-energy level. Now you know this. SPDF, you have heard about it. You have done inorganic in your classes. SPDF. Okay. So there you go. There are energy levels and there are sub-energy levels. First quantum number completed. Second quantum number completed. People, now, what is the third quantum number now? You're curious to know what is the third quantum number. You call the third quantum number magnetic quantum number. What do you call it? The third quantum number, you call it magnetic quantum number. එකට කියන්නේ M sub L කියලා. Internationally, you call it like M sub L. ලංකාවේ නම් ඉතින් like in Sri Lanka, some teachers call it ML. අමාරුකට එක ඒවා කියනවා. But I like to call it M sub L. So anything you can call it, they won't ask the pronunciation. හරිද? මේකට මම short note වෙනම කියන්නේ මම වෙනම board එකේ ලියන්නම්. I'm going to write a short note on the board separately. Don't write anything what I'm writing. Okay, this is just for the explanation and for you to understand what's going on. First quantum number done. N is done. Second quantum number done. Third quantum number, you call it the M sub L. You call it the magnetic quantum number. The magnetic quantum number. Okay. People, these sub-energy levels, or you think like they are circles? They are not. They are not circles. There are some are circles, some are dumbbell shape, some are like having a very complex shape. You can't think like O levels. When it comes to A levels, it's a completely different story. It's a completely different story when looking at an atom, because like electronic configuration also, like during O levels, you wrote it like 2881. In A levels, you write it 1:2:2. Like, this is wrong. You're learning something wrong in O levels. You can't write it like that. That's wrong. Okay? Think differently. Magnetic quantum number. Now, people, I will tell you for each and every M sub L. There's an equation. There's an equation for that also. M sub L is equal to minus L to plus L. Minus L to plus L. Hurry. Minus L to plus L. Now we wrote people Isalaman live L equals 0, L equals 1, L equals 2, L equals 3. You got it? L equals 0 now M sub L values. What could it be? Minus L to plus L. Minus L to plus L. Then minus 0 to plus 0. There's only one then, right? ML is equal to 0. M sub L equal to 0. Only one is there. Hurry. Yes, there's only one. L equals 1 people. M sub L can be, repeat after me, 1 minus L to plus L. So minus 1 to plus 1. Minus 1, 0 plus 1. Minus 1, 0 plus 1. Easy. Minus 1, 0 plus 1. L equals to minus 2, minus 1, 0, plus 1, plus 2. Correct? L equals 3, minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. There you go. These are the magnetic quantum numbers that can exist. These are the third letters. Madhakada Isela I wrote at the beginning of the class, I wrote 2, 0, 0, plus half. Madhakada. So that is N equals 2, L equals 0, and M sub L equals 0. So it's like here. Do you get it? It could be here, like another atom, could be like here, 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 wherever it is. It can be anywhere. Just have to find it out. Okay. Now, people, revising the parts which I have done. Now it's 20 minutes since I started the class, the Pomodoro technique. I'm going to apply it to revision class also. Again, I'm going to teach you 20 minutes and I'm going to take 5 minutes and revise the parts which I did before. Like quickly revise the parts which I did before for you. We talked quantum numbers. So what are quantum numbers? Quantum numbers means the address of an electron. Address of an electron. So this address has 4 letters. Letters numbers. This address has 4 numbers. What are the 4 numbers? The first one, the principal quantum number, you call it N. It can be 1, 2, 3, and so on. The second quantum number, what do you call it? The azimuthal quantum number. That fancy name you have, azimuthal quantum number. You call it L. L can be 0 to n minus 1. 0 to n minus 1. Okay. Next one. L equals 0 කියන්නේ what do you call it? S sub energy level. L equals 1 කියන්නේ P sub energy level. L equals 2 කියන්නේ D sub energy level and L equals 3 කියන්නේ F sub energy level. I hope you understood that. The next I told you the magnetic quantum number, the third one, the magnetic quantum number. In that paper, how do you calculate it? Minus L to plus L. Whatever the sub energy level it is, let's say L equals 1. When L equals 1, it can be there in 3 places. When like it can be there in minus 1, it can be there in 0, it can be plus 1. Do you understand? Lazy neither. One more thing I'll tell you. People consider this one number as one box. This one number is one box. That's all. One number is one box. This m sub l 0 කියන්නේ 0 නේ. කියන්නේ 0 නේ. That's only one box. ඒ box එක මම මෙහෙම ලියනවා. I'm going to write it and then I'm going to number it as 0. එහෙම. Okay? Then this one, there are 3 boxes. Minus 1, 0, plus 1. Minus 1, 0, plus 1. The next one, m sub l, minus 2, minus 1, 0, plus 1, and plus 2. That means there are 5. 1, 2, 3, 4, 5. Minus 2, minus 1, 0, plus 1, plus 2. Likewise, for this last one, you have how much? 1, 2, 3, 4, 5, 6, 7. There you go. So these boxes are like houses where the electron can stay. Where the electron can stay. Okay. Then මෙහෙමනේ. The next quantum number. ඒකට යන්න කලින් I need to tell you something. People, දැන් මෙහෙමනේ. When L equals 1, what do you call it? T sub energy level නේද? T sub energy level. What do you call L equals 0? S sub energy level. What do you call L equals 2? D sub energy level. And this is F sub energy level. Now I'm going to improve your knowledge further one step forward. Listen carefully. Now you need your imagination. You need your imagination right now to make all of this make sense. I'm going to make all of this make sense to you. The L value, when it was people 0, m sub l was only one number. Why? When L equals 0, m sub l can be only one number. Why? Why is it? A student can ask why. I only told you m sub l can be like minus L to plus L and it can only have one number. Why? When L equals 1, you can have 3 numbers. Like minus 1, 0 and plus 1. Why? What is this? මොකද්ද? කොහොමද? How? In Tamil, how do you ask how? I don't know. ඒකත් අහනවා. Right. People, L equals 0 කියන්නේ S sub energy level. Right? It's a S sub energy level. Trust me or not, it is a sphere. It's a sphere like a football. It's like a football, people. A sphere, no matter how you orient it, it's gonna stay the same. Like it's the same. No matter how matter you turn it here and there, it's still a sphere. It's like a football. There's no orientation for the ball. Do you get the idea? There is no orientation for the ball. So people, S sub energy level is like a ball. Like this. It's like a ball. And people, there is only one box, right? Inside there's one box. Maybe one box, like you can put electrons inside this. This one, L equals 1, P sub energy level. People, P sub energy level is like, you blow 2 balloons and keep their tails together like this. Can you imagine that? Like a dumbbell. It's like a dumbbell. This is the P sub energy level, L equals 1. You can turn this way also. Isn't it? This is in the y-axis. This is in the x-axis. You can draw another one coming out of the board in the z-axis. So there are 3 orientations. Do you understand? That is why there are three numbers. If the electron is moving in the x-axis like this, then that is m sub l. Whatever the number you give, එකට හරියට number එකක් දීලා නැහැ. It could, if this is -1 and this is 0, the other one coming out of the board will be +1. Do you understand, people? If you have listened carefully, you should be able to understand what I told perfectly, right? You understood it perfectly, right? Everyone in the meeting, there are 44 members with me. So please respond. The other one is coming out of the board. Like I can't draw it නේ මේක එළියට ගන්න බෑනේ. හරිද? So other one is coming out of the board. අනියා මෙහෙම අඳින්නම්කෝ. Or else like whatever, I don't know, like draw it like this. This is the z axis. හරිද? No need to draw in the tute I have given you. Z axis, this is the y axis. This is the x axis. So there are three orientations. There are three orientations. Now don't think the same way for the other one, like L equals then 0 mehemanang 1 mehemanang ayya. Now can you draw L equals 2 also? I can't draw it on the board. It's impossible. You can check Google. The orientations are very impossible to draw on a 2D plane. It's like very hard to draw. I won't draw them, but when L equals 2 people, there are 1, 2, 3, 4, 5 orientations. There are 5 orientations. And when it comes to L equals 3, there are 7 orientations. The F orbitals. F sub-energy level contains 7 orbitals. මොකක්ද කිව්වේ? The F sub-energy level contains 7 orbitals. I told a word which I shouldn't tell you right now, but I told it orbitals. What is an orbital? These are orbitals. These are orbitals. M sub L -1, M sub L 0, M sub L +1. This is one orbital. This is sub-energy level. Sub-energy level can contain 1, 2, 3 orbitals. Okay, don't mix the fact. Don't mix it up. Okay, now you understand everything except for the last quantum number. You understand everything except for the last quantum number. The last one, people, the last letter, very easy. There's nothing, people. I wrote like +half කියලා ලිව්ව මතකද? People, would you like to die single? Anyone here? Like, some people are there, they do not want a relationship in their entire life. So, okay. There are some people like that also. But electrons, trust me, sir, I understood the orientation concept. I told you, right? You need to like. You want to die single? Okay, fine. In S sub-energy level is orbital S sub-energy level orbital equal to 0. Yes, M sub L equal to 0. That's correct. There's only one orbital for the S sub-energy level. People, in a normal house in Sri Lanka, normally people are සාමාන්‍ය, like did you do like in grade 4, 5, 6 and did you do health or something, or civic education or something? Did you ඒකේ තියෙනවානේ the types of families, nuclear family and extended family. In the extended family ආච්චි ඉන්නවා, සීයා ඉන්නවා, බාප්පා ඉන්නවා, නැන්දා ඉන්නවා, like there's the aunt, uncle, grandmother, grandfather, grandfather's grandfather, and everyone is there inside the home. හරිද? People, in an atom, the God has told in an orbital, you can put only 2 electrons and not more than that. Only 2 electrons, not more than that. Only 2 electrons and not more than that. Do you understand the concept? So, this is one box, one orbital. If there are 2 people inside it, let's say like husband and wife. This is the husband. And this is the wife, let's say. People, they are inside one box, right? They're inside one box. Take it away. For example, consider, let's say, beryllium. Beryllium. Beryllium's electronic configuration, I hope now I'm doing a revision class now, I'm not doing a theory class. If it's a theory class, I won't go to this fact. Electronic configuration like normally you have 1s2, 2s2. That's all. Huh. This is the last one. This is a S sub energy level. 1s2, 2s2 ne. S kyanne S sub energy level lega. This one only you have here. There are two electrons, 1s2, 2s1 and 2s2. The two electrons are here. Okay? The two electrons are here. Now this guys, the quantum numbers, let's see n equals 2. How is n equals 2 and L equals 0? S ne? S ne? How is L equals 0? And M sub L value also 0. People, Pauly told, who's Pauly now? Pauly, who's Pauly? There was a scientist named Pauly. My monkey, he only told. He told two electrons cannot have the same set of quantum numbers. Two electrons of the same atom can never ever have the same quantum numbers. Like two people can't have the like anything. Two people can't have the same fingerprint again. Like they should be identical. They can't be identical to each other. That's what Pauli told. So he introduced the new quantum number M sub S. You call it the spin quantum number. Easy to understand. Only two values are there. Either it's spinning clockwise or either it's spinning anti-clockwise. Again, these electrons are spinning actually. Some electrons are rotating like this. The other electrons are rotating like this. One clockwise, one anti-clockwise. I'll tell you a small thing to do. Take your hands like this. Take your hands like this. Rotate the right hand to the forward and the left hand to the backward at the same time. Can you do it? Like this? Right? If you get a headache, I'm not responsible for that. Some people can't do it. This electrons, however, does that. One electron is rotating clockwise and the other electron is rotating anti-clockwise inside the same box. Interesting. So the person who is spinning clockwise, you call it plus half. The person who is spinning anti-clockwise, you call it minus half. Quantum numbers theory done. Okay. There's some small, like I have made the cake right now. I need to put some icing on it here and there. I'll revise this part with a short note now for you to write it. Now take that A4 sheet. I told you, put the topic quantum numbers. And I want you to draw this table big landscape view. Just think this is the A4 sheet. You like the topic quantum numbers on the top? Quantum numbers. Principal quantum number is the first one. How is the principal quantum number? Next one is azimuthal quantum number. People, you call it another name. මේකට තව නමක් තියෙනවා. මේ angular momentum quantum number. ඒක ටියුට් එකේ දීලා තියෙන්නේ. Azimuthal quantum number, or you can call it angular momentum quantum number. මම මෙතන azimuthal විතරක් දානවා. This is called the L value. This is the N value. So people, මෙතන ඉස්සෙල්ලා දාන්න equation. Like how to take. For the principal quantum number, you don't have an equation, you just put it a dash. People, L value, you can take it by counting from 0 to n minus 1. How is it? 0 to n minus 1. That's the azimuthal quantum number. Next one, magnetic quantum number. No memorization, just logic. I told you everything. So it's just logic. It's like you want to like connect them together. You know different parts right now. It's like connecting them together. You can do any question from quantum numbers. Okay, like if you understand the concept, you can do any hard question from quantum numbers. දැන් අර පටන් ගන්නවනේ මේ midnight accelerator එක. Okay, මම අමාරු questions. I'm going to give you some very hard questions also. May from these parts. Magnetic quantum number m sub L. So within this week, this topic should be perfect. There is no procrastination here. Within this week, this topic should be perfect. This is one MCQ, people. I will be teaching every week, and every week you're getting 1 mark. Trust me, every week you're getting 1 mark. And you might be counting like how many weeks are there to the exam. Like if there are more than 100 weeks, will I get 105? Like common sense, right? But I told this every week there will be a theory part where you can score at least 1 mark in the A-level paper. Understand that and come to the class. Okay, understand that and come to the class. If you don't complete it, I know you understood this perfectly right now, most of you. Majority, maybe 99%. Other 1% might be like deviated somewhere, like looking in social media or something right now, using the phone, watching status or calling someone or texting someone, whatever it is. Let's say 98% is focused. If you're focused on this, you would understand this right now. And the thing is, you will forget. Of course, you're human. Tomorrow you will forget this. Revise. Look at this. Draw this again. Take a rough sheet and draw this again. It's not about reading. It's about writing, people. It's like taking stuff out of your head. I told you in the special meeting. It's about taking stuff out of your brain. Then make a පාඩම් කරද්දී I don't want you to just read this. That is not how you study. Don't read this. No, reading isn't studying. Reading, if you want to read, go and read like in the library or something. There are many books in the library, you can go and read. But in A levels, reading isn't studying. Reading is not studying. If you like, reading can be done to study, but it's very slow. It's very slow. But if you like, when I finish this short note, people, then මම මේක බලාගෙනද ලියන්නේ. Like I'm looking at somewhere, නිකන් මේ screen එක පිටිපස්සේ there is a book or something, I'm looking at that and right now. I have written this many times possible, now I can do it. I can even explain it to someone. Richard Feynman told people, like, if you understand something, you should be able to teach it to someone, right? So you better write this again tomorrow in a rough sheet. මම ලියන ටික ලියන්න equation and everything. L equals 0 to n minus 1. M sub L is equal to minus L to plus L. Hi, minus L to plus L. Spin quantum number, ඉතින් අවුලක් නෑනේ. There is no equation. Spin quantum number m sub s. ඒකට මුකුත් නෑනේ, people. It's either plus half or minus half. ඒකට දාන්න plus or minus half. We can't predict which electron is plus half, which electron is minus half. You can't predict. So you can put plus or minus half. Okay. This is the equation. This is the equation. Now, people, when n equals 1, L value is possible. මොනවද? minus 0 to n minus 1. එතකොට 0 විතරයි තියෙන්නේ. Only 0 is there. Okay. So L equals 0 කියන්නේ මොකක්ද? This is a S sub energy level. What do you call it? S sub energy level. S sub energy level. What else did you learn about it? S sub energy level, L equals 0. And also you learned another thing. It's like a sphere, right? It's like a ball. Ball. There is only one orientation also, right? There's only one orientation. This is how you work. This is how you work, people. If you can recall this information one by one, that's what's called learning. 0. M sub L 0. Spin quantum number plus or minus half. You can't tell which one it is, just plus or minus half you can put. Okay, that's plus half and minus half. Okay. When n equals 2, n equals 2 people, azimuthal quantum number L can be two values. It can be 0 or either 1. I'll put 0 here and I'll put 1 here. So it's like branching. See? It's branching. Magnetic quantum number, when it's 0, it is just 0. Okay? When it is 1, there are 3 actually. There is -1. I'll put the 3 boxes like this. -1, 0, and +1. And it will branch into 3. You can see here, there are 3 orientations. What you call this P sub-energy level. Make a sub-energy level sub-shell. You can write it as subshell. 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 If you want, you can tell that me tongue twister. Well, she sells seashells in the seashore. I can't tell it when I was small. Trust me. I was like, she sells come to the sea and sells seashore, whatever I told back then. This is the P subshell. So what's the shape of it? It's a dumbbell. There are 3 orientations in space. There are 3 orientations in space. Okay? Okay. Spin quantum number can be plus or minus half. Right? Plus or minus half. This one also plus or minus half. Hari? One is enough. Right. That is the n equals 1 and n equals 2. So when it comes to n equals 3, it will branch into 3, 0, 1, and 2. And 2 means what? D subshell. And the shape we don't have to learn about it. It's a complex shape. There are how many orientations? There are 5 orientations for D orbital. Sorry, D sub-energy level. And spin quantum number is always either plus or minus half inside one orbital. Okay. So you call this one orbital, ne? You call this one orbital. මේකකට අපි කියන one orbital කියලා. This is an orbital. This is an orbital. 0 people, there's only one orbital. 0 වල තියෙන only one orbital. I will only do for n equals 1 and n equals 2 only. Okay. Right. I'll tell you something which they haven't asked in A-levels yet. There's an MCQ which they haven't asked in A-levels but predicted to be asked soon. They didn't ask in 2025. You will get this now. Like I put the plan for the paper class. එතකොට අන්තිමට තියෙන අර ATP මොකද්ද මන් දෙකක් කියලා. ATP කියන්නේ A-level target papers. In that paper set, you will be getting target MCQs and target essay questions for the A-level paper. ඒතකොට ඒවට එහෙම included. And the shadow paper series, මොනවද shadow papers කියන්නේ? Shadow papers කියන්නේ, let's say 2017 A-level paper, you guys have probably done the paper by that time. What I am going to do is I'm going to take each and every question out of that A-level paper and I'm going to create a shadow of it. Again, that same question, I'm going to shadow it to another question, which is like a little bit hard and similar to that question. One step further. Those are called shadow papers. And prep papers, around 8 prep papers we are going to do. 1 week MCQ and 1 week essay. Online also you can write, and physical also you can come and write at Faraday. Okay, people, I'm going to erase the board now. I hope you have written this. Now I want to put some icing on this. A small icing part I need to put. Read the tute. Take the tute PDF. Tute PDF. Depending on the energy of electron, now the top part below the topic quantum numbers, depending on the energy of electrons, they have different quantum numbers. I didn't tell that later, right? Like that time I didn't tell you. Depending on the energy of electron, people, these quantum numbers represent the energy of that specific electron. It represents the address, but depending on where the electron is, it has different energies. Depending on where the electron is, there are different energies. If the electron is in n equals 2, it has a larger energy than n equals 1. If the electron is in what you call p subshell, then it has a larger energy than s subshell. And there's an energy also within these quantum numbers. So if the electron is in like upper energy levels, then it has a large energy. Right? Okay, a set of quantum numbers is like an address to the electron. If we need to find the location of the electron in the atom, we must look for its quantum numbers. There are 4 sets of quantum numbers which describes its address. The first one is n, the second one is l and m sub l and m sub s. I have explained these things to you right now. The first one is principal quantum number. Principal quantum number represents the main energy level of the electron. When the electron goes to upper energy levels, the energy of the electrons will increase. I told you, when going to upper energy levels, what will happen? Energy of electrons will increase. The principal quantum number can determine 2 things. First thing, it can determine the energy of the electron. Okay, if it is in a higher energy level, then larger energy. Lower energy level, lower energy. It can like be used to represent the energy. Second one, it can represent the size of the orbital. People, when you consider like higher energy levels, large energy levels, people, they have large orbitals too. People, for example, p orbital here, මෙතන ඉන්න p orbital එක, when it is n equal to, it is smaller than when it is n equals 3. That means like size also can be determined. Size also can be determined. Electron spends more time further away from the nucleus. Like when the principal energy level increase, the electron has to go a large distance. It's like Uranus, Neptune, and Pluto, which is like kicked out of the class. Pluto is not there. I liked Pluto back then, but it was kicked out because it's very small and it's too far away. They considered it as a moon now. So sad, right? There is a Pluto, organizations and everything in Facebook trying to bring it back. Ridiculous people, right? Then next one, people, azimuthal quantum number, angular momentum quantum number. So L is less than and equal to n minus 1. Again, from 0 to n minus 1. Same thing. Azimuthal quantum number represents the sub-energy level of an electron. It's always less than or equal to n minus 1. So when n equals 1, L can be 0. When n equals 2, L can be 0 and 1. N equals 3, 0, 1, 2. N equals 4, 0, 1, 2, 3. There you go. What does it mean when L equals 0 or L equals 1 or L equals 3 or L equals 4? So what? Like, it represents the shape of the orbital. Highlight that. I don't have the PDF. You don't have the dude to highlight. Remember that. It represents the shape of the orbital. In an A-level paper. What does the azimuthal quantum number represents? And one answer is like this. It represents the shape of the orbital. And that was the correct answer. So they have asked it before. The azimuthal quantum number represents what? The shape of the orbital. Like when L equals 0, it is a sphere. When L equals 1, it is a dumbbell. When n equals 2, like something complex. When L equals 3, it's even more complex. L equals 3, yeah. If orbital, it's even more complex. People, when L equals 0, it represents an S orbital, sub-energy level. Correct that when you get the dude. There's only one S orbital per energy level. When L equals 1 represents the p orbital, then there are 3 p orbitals according to orientations in space. You can see one is in the x-axis, one is in the p-axis, y-axis, other one is in the z-axis. So there are 3 orientations in the space. This people m sub L values, which are going to learn later, will describe this orientation, like x-axis y-axis z-axis. So it will tell you, the magnetic quantum number will tell you the orientation in the space. Understood? It will tell you the orientations in the space. When L equals 2 and L equals 3, people, d orbitals are represented by L equals 2 and f orbital represented by L equals 3. The different d orbitals in a given shell have different shapes and orientations in space. The shapes and shapes of the f orbitals are even more complicated than those of the d orbitals. We don't discuss them in our syllabus. Energy of orbitals vary as follows. Orbitals of same energy level. Within the same energy level, the energy will vary according to what's given here. P is larger than S, D is larger than P, and F is larger than D. Then we energy variation you're going to learn more deeply when it comes to Aufbau rule, which is on the next page. We're going to learn that today also. Next one, people, magnetic quantum number. Magnetic quantum number describes the orbitals within a sub-energy level within SPDF orbitals. We normally represent them with boxes. They have same energy, shape, and size. Highlight that when you get the tute. Highlight that when you get the tute. They have the same energy, same shape, same size. The only thing that differs is the orientation in the space. It's like you have twins. One twin is sleeping on the x-axis, other twin is sleeping on the y-axis, other twin is sleeping on the z-axis. Now you may be wondering now, how is the person sleeping in the x-axis? Like the bus again. Like in the bus people, some people are standing and sleeping. I have seen. They are standing and sleeping. I don't know how, but they are doing it. Like even if the brake is applied, that person is holding it tightly and he won't fall. I don't know what's going on, but things like that happen. People can sleep. People can sleep while standing. Elephants also do, right? Spin quantum number, the last one. One orbital or one box can have two electrons. They have spinning directions. They spin in opposite directions. So when you get the tute, you have to write there plus or minus half. It can spin clockwise. It can spin anti-clockwise. Okay. That's it. Quantum numbers. Theory is over, but the icing parts are the Aufbau rule, Hund rule, and the Pauli's exclusion principle. Those are the icing part of the quantum numbers section. You can do question patterns now. There are certain question patterns which you can do now. There are some question patterns which you can't do now. I want you to understand until electronic configuration in order to do questions in quantum numbers, because they are combining electronic configuration and quantum numbers together when asking questions. Okay, 5 minutes. Just look in another direction and like walk somewhere and come back to the screen. Have some rest. 5 minutes only, okay? Before going to the next topic, I want you to like refresh yourself. I have revised all the parts which I have done until now. 2 Pomodoros done. That is 30-minute sessions. 2 30-minute sessions. It's 8 p.m. now. Nice cover page, right? Look. This one. In this, you have quantum numbers section. There are 15 questions there. Essay type and also MCQs. People, did you understand this everything now? Like, was it clear to you? Drop me a message. Ternani? Yes. Cool. Sir, to be honest, I had been struggling with quantum numbers all this time. Now only I did get them and their meanings. Very good. So happy to hear that. Very clear. Okay, good. People may, it's not at all okay. You have to do questions, and when you do questions, you will find yourself wrong, and you will think again. Now I can't understand again. So you have to do questions perfectly. Also, that's only when you completely understand quantum numbers. Still, it's just the theory. There are some signal issues for some people. So sad to hear that still some places are like down in signal. What a big disaster, right? No, 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 it's fine. I was Ammi saw you on the screen and she was like a young man teaching, impressed. Okay. I was doing this since last year. Right after my A levels, I started teaching. Didn't take a cent from home after my A levels until today. I haven't taken a single rupee from home. I have given them also money. Like I have given them all the money they have paid for me during A levels. I have given them back. So tuition is a good field if you want to come in future. But if you only have the ability to take others, negative comments and like අර මඩ ගහනවා කියන්නේ හරිද ඒවත් I have listened to many of them හරිද ඒවා අහන්න පුළුවන් වෙන්න ඕනේ and you should be able to teach හරිද this is not an easy thing to do typing your tunes and everything and the papers marking schemes like 24 hours I'm on that. Again, 24 hours I'm on that. I'm not sleeping again. But what I mean is like overall majority of my time I'm giving to that. So it's a good field if you want to come in future, right? People, next one. Now come back. People, everyone come back. අන්න meeting එක 36ට අඩු වෙලා එපා. There were 42. හරිද? See? People can't give the focus for many long. ඒ කියන්නේ දන්නවනේ මේ game එක ලේසි. Like just imagine if I was famous, I was very famous, let's say 1,000 people join this meeting. එතකොට after like 1 hour you will see 200 of them go. It's a ratio. Now 42 වලින් around 8 or something, some people signal issues, of course. So let's say 5 people left. So that's a ratio. That ratio will always stay the same. No matter how much the student count is, it will always stay the same. I'm not yet famous. I'm struggling to do that in future. Should we complete the short note chart fully? Yes. If you want, you can do it. If you understand the concept, then fine. Okay, come back now. We are starting Aufbau rule. Aufbau rule, police exclusion principle, Hunt rule, and electronic configuration all together. People, now you learned quantum numbers. And if God told you to fill electrons into orbitals, how would you fill it? If God told you to fill electrons into orbitals when creating elements of the universe, how would you fill it? That's what Aufbau told. Aufbau is not a god, but he's a scientist. I'm just telling a story. Just a story. Aufbau told, this is how you fill electrons into orbitals. How did he told? It's easy, very easy. Just look at this value. Patta easy make. Hari one 1s, 2s 2p, 3s 3p 3d, 4s 4p, 4d, 4s 5s 5p. Metani not like this is enough. 5d. How many I think. What you can do is you just need only one pen or a pencil. You cut using an arrow. You fill two electrons to the S1. හරිද? ඒ කියන්නේ S එකට දෙකක් දාන්න පුළුවන්. 1s2. Then you fill into 2s. Then you fill into 2s. 2s, two electrons you can put. කියන්නේ එක box එක ගන්න people 1 S එකක් කියන්නේ 0 with m sub l value 0 and L equals 0. It's 1s sub energy level නේ. ඒක ඇතුලේ තියෙන්නේ only one orbital and you can put two electrons inside it. So it's like 2s2. Understood, right? Nice. Then people next one may now you cut here you find 2p and then 3s. So 2p 6. There are 6 electrons. Don't forget. Remember, there are 3 boxes. Then L equals 1 with m sub l values -1, 0, and +1. There are 3 boxes, right? So there can be 6 electrons. 1, 2, 3, 4, 5, 6. There you go. Total of 6 electrons can be inside it. How would you fill electrons? That's how we told. Again, how would you fill electrons into sub-energy levels? That's what Aufbau told. But his theory was not complete. There was another scientist who came later. Now, Hund rule. Hund told that how to fill electrons into these boxes. Again, like how are you going to fill electrons into these boxes? Like, is it like 1, 2, 3 like this? Or is it like, you can fill it anyways, like 1, 2, no, it's not like that. You have to fill it one by one. 1, 2, 3, 4, 5, 6. Now, what did Aufbau told? Aufbau told you which sub-energy level you should fill. Make it a pass maker, make it a pass maker, make it a pass maker, make it a pass maker. After this, after this, like this, like this, like this. You cut using arrows. Like this, okay? You cut using arrows. Okay, right. That's how you fill electrons into sub-energy levels. You have this in your tute. Look, filling of electrons in an atom begins with the subshell with the lowest energy and continues upwards. Anna, important word, the energy. Well, this is the energy variation. This is the lowest energy, and then this one, and then this one, this one, this one, this one, this one. Likewise, the cutting order. That's the energy increasing order. Another question pattern unlocked. Arrange the following in the increasing order of energy, and they will give you this one, this one, this one, this one, this one. You have to arrange them in the increasing order of energy. Let's draw this, cut this, and write the increasing order, energy increasing order. 1s is the lowest energy, and then 2s, and then 2p. Likewise, it goes on according to this variation. All right? That's all. 1s orbital has the least energy and it goes on down. That's it. Now look people, next on Pauli's exclusion principle. What does that guy tell now? Pauli, who's Pauli? I told you like when I was talking about spin quantum number, I told you a scientist named Pauli. And Pauli කියපු එක තමයි මේ තියෙන්නේ. No two electrons in an atom can have the same set of 4 quantum numbers. මට ඔක නින්දෙනුත් කියනවා ඒ කාලේ. හරිද? I like studied this so much. No two electrons can have in an atom can have the same set of 4 quantum numbers. That's what Pauli told. What did Pauli tell? No two electrons can have the same set of 4 quantum numbers. Again, ඔක්කොම හතරම equal වෙන්න බෑ කියලා කියන්නේ. Either like it's going to change in the m sub base value also, either plus half or minus half, plus half or minus half. Okay. This indicates that an orbital can hold a maximum of 2 electrons and they must have opposite spins. This restriction allows us to address the electrons in an atom by giving their quantum numbers. So that's what Pauli told. No two electrons can have same set of 4 quantum numbers. And it can be either spin into clockwise with the plus half m sub base value, spin quantum number. Or it can spin other side with a minus half spin quantum number. Next one, the last one, Hund rule. People, Hund rule states that for degenerate orbitals, what is degenerate? What is degenerate? People, degenerate කියන්නේ equal energy. Equal energy. Degenerate නැත්නම් same energy. හරිද? The lowest energy is attained when the number of electrons having the same spin is maximized. 100 states that for degenerate orbitals, lowest energy is attained. If you feel like this, if you feel like this, it's going to be unstable. Unstable. This guy is unstable. You don't feel like this. This Hund told that Hundo Hund. Some people say Hund. Like I'm like seriously, when they say Hund, I laugh out loud. Class among is me first shy. I went to English medium class. So I was like Hund. I was like, why? Like it's called Hund rule. Like I don't know why some people call it like that. Whatever you can call it. I told you they are not looking for the pronunciation. Hundo, Hundo, anything, whatever, right? So you feel it like this. One by one orbital and the next orbital, one orbital at a time, one donkey at a time, right? One orbital at a time, one by one. This is stable. So this is not how you feel. This is how you feel. This is what may Hunt rule taught. Okay, now the three rules you know. You know the three rules now. One more thing. People, these orbitals have same energy. No matter the electron is in what you call this box or this box, doesn't matter. I told you they are having different orientations in space. They are equal to each other. People, this is a p orbital which is in the x-axis. This is in the y-axis. No. This is in the y-axis. This is in the x-axis. This is in the z-axis coming out of the board. Understood, right? So they don't have different energies. They have same energy. So you call them degenerate orbitals. What do you call it? Degenerate orbitals. Okay, people. Next one. What are the three rules now? What are the three rules? What are the three rules? First one. What is it? Aufbau rule. What did Aufbau rule? The energy increasing order for sub-energy levels are a cutting order. The thing, right? Cutting order. Second one, what? Pauli's exclusion principle. What did Pauli told? No two electrons can have same set of 4 quantum numbers. That's it. No two electrons of the same atom. Atoms, that's a different story. Same atom, no two electrons can have the same set of 4 quantum numbers. Okay? People may, there are parallel universes, right? Now, it's going to waste time. We have limited amount of time. Okay, next on. I can't tell these things, people. This time it's only 8 months, and last time I told these stuff. I can't tell it this time. It's going to waste time. Right, next on, may Aufbau rule, Pauli's exclusion principle, and then finally the Hund rule. Hund rule. What does it tell? You have to fill electrons one by one. Into degenerate orbitals, you have to fill electrons singly. Singly one by one. One by one only you have to fill. Right? There are different question patterns coming out of this one also. When you are doing MCQs, you will understand there are different question patterns coming out of these 3 topics also. Because now your quantum numbers knowledge is like 90% done. Still 90%. Like what is the next 10%? Electronic configuration. I want you to learn electronic configuration, and then you will be fully completed. People may exercise fill 2 electrons into the following orbitals. Like you know how to fill, like one by one. It's like this. How do you fill? There are 5 boxes. 1, 2, 3, 4, 5. You fill the next 2 electrons, not here, but here. Like this. Okay? Like that. So these boxes have may addresses. What are the addresses? May are 0, may are +1, may are +2, may are -1, may are -2. Hurry. That's +1, +2, and this one is -1, -2. Hurry. Next one. You have to fill 2 electrons into this. Trust me, people, you won't find anywhere in Sri Lanka English medium class who teaches quantum numbers and everything like this. Trust me, you won't. Because I also have been a student. I haven't seen anywhere like this because I went to a single medium class because there are not enough teachers in Sri Lanka who is doing English medium properly with a proper plan. මන්නම් දැකලා නැහැ හරියටම. ඒ කියන්නේ අර like in order to help a student who is in the S level or like who is having an F level ඒ වගේ කට්ටියට උගන්වන්න සර්ලා මන්නම් දැකලා නැහැ. I have seen teachers who will create ranks and all, but I haven't seen students who will increase their marks. The best example is you go second shy to them, like the famous teachers in Kandy and Colombo, whatever. Second shy, you don't go to them. Many students go to single medium class in the second shy. And you know what? Who am I telling about? You know who am I telling about, right? I also went to that person, second shy. That's the best example. Second shy, they go to single medium classes. Why? Because they give an English medium tute and like, එහෙම තමයි. That's the problem. Like, that's the problem. So true, right? That's what I told. I want to fill that gap for chemistry. That's what I'm doing this. I'm not telling I'll be perfect, but want to just try out. Fill the two electrons like this one by one. You fill into this and then into this. Okay, then people may. Now we can combine the three rules together to understand how to write electronic configuration of an atom. You have to learn how to write the electronic configuration. Okay, now you have to take out a periodic table. If you don't have a periodic table, you can search it in Google, you will find it. Now there are two topics under this. Three topics actually. The normal procedure and the second one should be exceptions. There are some exceptions you need to learn other than the normal procedure. What a degenerate. Degenerate orbital කියන්නේ the orbitals with same energy. Degenerate කියන්නේ like same energy. For example, in P. This is a P subshell. In P subshell, there are three orbitals, -1, 0, and +1, right? Can P කියන්නේ මොකක්ද? L equal 1 නේ. L equal 1 has how many m sub L values? -1, 0, and +1. So there you go. These are these. And they have same energy, right? They have same energy, so you call it degenerate. Okay, Muzaina? Yes, issue I'm uploading the recording. Internet connection issues තියෙන කට්ටිය you can manage it. I'll be providing recording anyways. Let's see. Right. People, when it comes to element in the periodic table, there is something called the atomic number. දන්නවනේ. මේව නම් කියලා දෙන්න ඕනේ නෑනේ. You know this, right? Atomic number is at the bottom and the mass number is on the top. 11 and 23. People, the number of electrons is represented by this one, this atomic number of protons and number of electrons. Also, it represents the number of electrons. Right? It represents the number of electrons. Actually, it represents the number of protons, but we can tell that it is equal to the number of electrons. Now look at this one. You remove one electron out. You just chase away one electron. And now you have sodium plus. Hurry. You have sodium plus. So do the electrons in different sub-energy levels have same principal quantum shell? Of the same principal quantum shell have same energy level, or does it increase? Different sub-energy levels of the same has Anna. You asked this one. When n equals 3, L can be 0, L can be 1, L can be 2. You're asking whether these guys have same energy level. Is that what you ask? Yes, they don't have the same energy. That's what we learned in Aufbau. Aufbau told හරිද? දැන් බලන්න 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, and 4d, 4f. දැන් බලන්න when we cut, you can see 2s, 2p, 3s. You find 3s. 3s is the lowest. This 3s 3s is the lowest, and then 3p, and then 4s is there, and then 3d, right? The energy is increasing like that. Do you understand? Did you understand? But me Aufbau rule. L equal 0 කියන්නේ S. හරිද? L equal 1 කියන්නේ P. And L equal 2 කියන්නේ D. Okay, right. If you have issues, then ask, okay? So you remove an electron from this atom, you have sodium plus. You represent plus charge when you remove an electron. හරිද? ඒ කියන්නේ people, does this number change? No, it doesn't. I told you it represents the number of protons. Then Aya, you also told the number of electrons කියලා. No, that's not what I meant. But when it is like in the ground state, again, without removing any electrons or gaining any electrons, then this is equal to this. But not always. In this one, for example, proton number is 11 still. But the electron number is 10 because you have removed an electron. The mass number also doesn't change. People, mass number again, මොකද්ද? Mass number means neutron plus proton, right? Neutron plus proton. So it doesn't change. So you understand the concept now. You can remove electrons, but you can't remove protons. You can't remove protons. In the A-level syllabus, you can't remove protons. If you want to remove protons, you have to do nuclear reactions. Hari? Right. So let's write the electronic configuration of different elements. The simplest one I'll tell you. Helium, easy. Atomic number is 2, right? In the periodic table, you have the atomic number. So how do you fill? Aufbau's filling order: 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, likewise goes on. So people, it's atomic number 2. You can fill it just to 1s2 and complete it. That's all. 1s2. You got it, right? 1s2. Hurry. I'll write a little bit complex one now. Let's say, people write this in an A4 sheet or something. Hurry, when you get the tute, you can complete it. Okay? Uh, 3D has more energy than 4S. Yes, of course. 4S is here. May people may don't cut it like මෙහෙම cut කරන්න යන්න එපා. You have to cut it like this. Okay? Like this. You are correct. 3D has larger energy than 4S. That's correct. ඒක තමයි මං කිව්වේ, you can't directly predict using the principal energy level. Sometimes it can change like this. Like 3D has a larger energy than 4S. That's a good question. You pointed out that. හරි, මේකට energy වැඩි මේකට වඩා. That's larger. Right. Then next one, I'll say nitrogen. People, nitrogen's atomic number, this will be 1s2, 2s2, 2p3. You can remember 2s2, 2p3. You cut it here. 2p3. Right? 2p3. Here 3 4 5 6 7. I'll tell you potassium now. Potassium means, I guess, 19, right? 19. Do you have periodic table? Anyone near you? In the cover page I have. Potassium 19. That's going to be now, you have to cut it like this and add the electrons. Huh? 1s2, 2s2, 2p6, 3s2, 3p6. And 4s. 4s what? Now you count and see. Now let's see. Will you? 6 and 2 is 8. 6 and 2 and 2 is 10. So 10 and 18 plus 1 remaining. So 19. 4 is 1. Easy. So the lowest means the first cut will have the lowest. Yes. 1s will be the lowest energy and then so on. Right. Then people, I'll tell D block element. D block element, this middle one. You have this middle like scandium, titanium, vanadium, chromium, manganese, iron, nickel, iron, nickel, iron, cobalt, nickel, copper, zinc, and below that's the D block you call it. Then people may, I'll draw it for like scandium. No, I'll put for vanadium. Well, vanadium atomic number 23. You don't need to memorize the periodic table in the exam. They are going to give it if you didn't know. Haril, dannani. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d. Now filling order. Haril, I'm putting it in the filling order. 4s2 and 3d. What? 3d 3. Is this correct? Is this correct? 2p have a larger energy than 3s. Yes. Monkey like cutting order, the pencil. The first thing that the pencil comes is the large energy. Can you remember? 1s is larger than 2s. 2s is smaller than like 2p, and then 3s likewise. Okay. People, is this correct? According to the cutting order, is this correct? According to the cutting order, is that correct? Tell me, tell me. Come on, people. බලන්න මේ 32යි මීටින් එක මං කිව්වේ හරිද බලත් එක්ක පැය ගණන් ක්ලාස් කරන්න බෑ like you guys can't hold it for like even 2 hours. I'm not telling for you people, the people who left. Okay, a lot of people telling it is correct. No, this is wrong. According to this cutting order, you might think this is correct, but we can't write it like this. We can't write it like this. Why? There is no perfect reason for that because like we tell it's ugly. Yeah, katai. Now look at you people. 1s is there, fine. 2s is there, 2s, 2p, like 2 is together, right? And then 3, 3, suddenly you have a 4 in middle. It's ugly, ne? It's like ugly, right? You can't write it like that. Yes. So what you do? You exchange these two with each other. You erase the whole thing and you write 3d3 and then 4s2. Likewise, only you write. Do you understand? You write using the cutting order and then you shift these two like this. Okay, now we have the 3's in order. That's beautiful. Right? Now it's nice. Now it's nice. Okay, people. Then one more thing I'll tell you, metana how the electrons are put in this d orbital, how the electrons are put. I'll draw in boxes 1, 2, 3, 4, 5. So there are 3 electrons. So 1, 2, 3. Alright, this is the 1, 2, 3. So people, this electron you call lastly filled electron. This electron you called outermost electron. And if they ask you to write the quantum numbers of the outermost electron of vanadium, then you have to write this one. N equals 4, L equals 0, M sub L 0, and M sub S plus or minus half. This one. What about this one then? Lastly filled electron. Lastly filled electron, N equals 3, L equals 2, and what? M sub L kiyada 0 ne. 0 minus 1 minus 2 ne, and this is plus 1 and this is plus 2. So 0. That's all. Lastly filled electron and outermost electron, you should have an idea. Sir, can't we say 3D, 5 and 4 is 0? Because partially filled are more stable. No, that one can't be done. That's an exception. That's an exception. Now, Hajira, right? That's an exception. We applied not for this one. We applied only for chromium and copper. I'll tell it later. This is okay. This is okay. When you have 4 electrons only, that issue comes. I'll tell it later. You can, this is the correct variation for vanadium. Okay, now we will, in the tute, when you get the tute, you have to write the next topic. එක print වෙලා නැහැ හරි මොකක් හරි වෙලා. You have to write the next topic. The exceptions. That is what this girl was saying. The exceptions. Should we have to write this? Of course. You know, like, why did I write it on the board? Like when you get the tute, you can come back and watch this recording. This recording will be there on YouTube, free for everyone, because this is a free class. It'll be free on YouTube for everyone. Whenever you want, you can come and check and then write the note. I can't write it again. Okay. Then people, next one. The normal procedure and then exceptions. There are like 2 exceptions. Mainly we talk about chromium. Chromium people, atomic number 24. එතකොට මේක ලිව්වොත් එහෙම 1s2 2s2 2p6 3s2 3p6 3d4 4s2 මෙහෙම තමයි ලියන්නේ. Like normally, according to the last thing we discussed also, we have written it correctly. Now 3 and 3 and 3 all together, everything is looking good. But this is wrong. This is wrong. Why? Wrong කියන්නේ මෙහෙමයි. Now the thing is, this 3d, this 3d, this 0, this is plus 1, this is plus 2, this is minus 1, this is minus 2. And this 4s2 is on the right hand side. This 3d will be like, it has only 4 electrons. And 4s2 is completely filled. 4s2 is completely filled. Now there's a story. Like there is something which we tell. Halfly filled. What is that? Halfly filled sub-energy levels are more stable than incompletely filled sub-energy levels. What the? Halfly filled sub-energy levels are more stable than incompletely filled sub-energy levels. You will understand this more when we go to future variations in the syllabus. Now we have to talk about a lot of variations. We are going to learn. In here also we can apply that in order to become stable. Now, fully filled also stable. Fully filled is like very stable. Like if I wrote the stability, fully stable is the largest. Fully, and then half, and then incomplete. People, now you can see Sri Lanka now. People are helping each other, right? People are helping each other, providing food and like shelter and like everything. The disaster came and then like, everything is happened like that. These electrons will also be same. Now this sub-energy level, this D sub-energy level will ask an electron from this S. Machang, I am incompletely filled. I am incompletely filled. You are completely filled. If you give me 1 electron, you will also be stable. I will also be stable. Will you give me 1 electron? So 4s will be like, okay, fine. I will give you 1 electron. He will move from fully to half, but it's fine. He will move from fully to half, but it's fine. He will give that electron to this orbital. And it will arrange in a structure like this. It will arrange in a structure like this. And this incomplete one will also move to half. Now everyone is happy. Do you understand? Yes. 3D sub energy 3D 5. Oh, no, no, no. We can't do that. 3D 5 කරන්න බෑ. If like මේක තව එකක් අයිතුර එකක් ගන්න බෑ people. එතකොට මේක move uncomplete වෙන නාරුගේ ඔක්කොම electrons එක ගන්නවානේ. You can't do that. Yes, very good. Nice. Okay, people. May right. Next one. Copper. Now this correct variation, correct electronic configuration is 3D5 4S1. How 3D5 4S1. So if we enlarge and rotate 1, 2, 3, 4, 5, 6. So people, this is the lastly filled electron. You call this the lastly filled electron. And this is the outermost electron. Outermost electron. Understood? So if they ask you to write the electron quantum numbers of the lastly filled electron, you have to write the electron which is here, which is going to be what? N equals 3 and L equals 2 and M sub L is equal to plus 2 and M sub S is plus or minus half. We can't tell which one it is, plus or minus half. Hurry. So that's how you write the quantum numbers for that one. After this part, could you explain quantum number of the outer electron and last electron? Yes, I'm going to give you some questions regarding it and we are going to discuss it again. That's why the class is until 11. Right. Then the next example I will tell you, copper. Copper people 29. Copper 29. Hurry. If you write 1s2, 2s2, 2p6, 3s2, 3p6, 3d9, 4s2. 3d9, 4s2. 3d9, 4s2. Now the D will be like, oh my god, like this, okay? 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. And 4s2 will be completely filled. Now the D will be like, bro, if you give me that electron, I will be fully stable. If you give me that electron, I will be fully stable. Fully stable. Haru? Fully stable. So copper will take the electron anyways. Haru, it will take the electron anyways. And it will arrange like 3D10 4s1. It will take that electron like this. It will take that electron. That's how it happens. It will donate the electron to the 3D. Because people, these are inner shells. You have to fill the inner shells before filling the outer shells. So that, you know, this copper will tell that thing. Like copper will tell this may 4s sub energy level, it will tell, bro, like, you know, don't do things like that. I need the electron. I need, like, I am the 3D energy level. I need the electron more than you. Just give me that. That's how the 3D energy level will be. And 4s can't tell no. So like it will take anyways. So these are the two exceptions. These are the two exceptions which you need to learn about. එතකොට people the elements below. Now below chromium will also do the same thing. Molybdenum. We don't have it in the syllabus. We don't talk about them. The element below copper, the silver. Silver also does that. But we don't like, you won't get questions from that. Only these two only they will question. Hurry. Then the last topic I want to talk with you. Condensing the electronic configuration. Condensing the electronic configuration. This is for the lazy people. කම්මැලි කට්ටියට මේක හරිද? Look, I'll give you an interval at 9, okay? 20 minutes interval. Um, Condensing an electronic configuration. Now look at this one. Calcium. People, calcium's electronic configuration, if you write, you can write it as 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. If you write the electronic configuration of the element above and to the most right, again, these noble gases, you have helium, neon, argon, krypton, xenon, radon, and then what is this? මොකක්ද අන්ත දෙනවා. හරි මේ you have to look at this argon. This calcium in මෙතන now calcium's above one and to the most right argon. If you write argon's electronic configuration, you will get 1s2, 2s2, 2p6, 3s2, 3p6. 3p6. So this is like, same thing here. Same thing, ne? Same thing. So how do you condense an electronic configuration? This calcium we can write how? Argon, put a square bracket and then put 4s2. Easy. But don't write this always. If they ask you to write the electronic configuration, don't write this. They will give marks, some marking schemes they have given, but not sure, ne? Write this one. If they ask to write the condensed electronic configuration, then write this. Don't write this then. Condensed electronic configuration is this one. And the normal one is this one. Write this. So you can do this for other atoms also. You can do that for the other atoms also. Hurry. People, I told you to buy a 200-page CR book or something like that in order to do questions. If you don't have like that, then take a rough worksheet or something. Lot of students have a connection issues, neither. Like 5 or 6 people told connection issue. Still the thing is going on. I mean, dialogue and all connection is down a little bit in some areas. Not like those days. Some people are scolding this dialogue and everything, but that's like very bad. They can't do anything regarding it. People, they are running optic fibers. Now, I have seen a lot of people scolding dialogue and everything like for breaking the internet. They don't do it purposefully. What happened is like dialogue has many cables, optic fibers only they are running. Hutch is running from microwaves, which is like the old technology. Hutch is running with microwaves. They don't have optic fibers. So people their internet is slower than dialogue. Dialogue එක මෙහෙම කරන්න people. Dialogue එකේ internet එක දෙන්නේ. Now let's say this is the tower. This is the tower. They are giving internet from one tower to another tower using optic fibers. This is how dialogue does it. මේවා කැඩිලා තියෙන people. Once the rain came and then these are broken. And don't think it's just one line people. මේක මෙහෙම හැමතැනම යනවා. Like there are many towers නේ. In Hutch people, what they do is they are sending me microwaves. That means they are sending me microwaves. And this is much weaker than optic fibers. You know it, ne? Much weaker than optic fibers. Will you be giving like shortcut tips to find way? Of course, I'll be giving. No issues with that. And also there was another reason. Power cut to these towers can't run people. So there's no use scolding them. The only thing is like you have to wait. Like there's nothing to do. What to do with it? Now Starlink, now iPhone 18 Pro, now the Apple CEO Tim Cook was like interviewing with Elon Musk recently, and he was like integrating the Starlink into the iPhone 18 Pro. පට්ටනේ හරිද? ඒවල තමයි ඩයලොග් එකට ෂොට් එක හම්බෙන්නේ. Dudes arriving I will be couriering now once everyone make payments. Now today's the free session. Sir, I've been having a power cut for a few hours now. My device might run out of battery anytime soon. Can I get the recording? Sure. Okay, now people, the theory part for today is done. Now I wanted to focus on questions. Again, then my real thing starts. Now only like, the real thing starts. People take that thing, unit 1 plus 2 workbook. In that, turn to quantum numbers plus Aufbau rule plus Hund rule part. In there, do the first one. Do the first one. Come on, do the first one. Do the first one, okay? I'll give you 5 minutes. 5 minutes at ini. Okay, 5 minutes, 5 minutes. This one, okay? I have sent the PDF to the group. See now this question, all the things are combined. Electronic configuration is there. The Aufbau thing, everything is also there. How is the condensed electronic configuration is there. May Aufbau තියෙනවා කියන්නේ මේ when writing electronic configuration you have to respect the Aufbau rule and write ne. So everything is there in this question now. That's why I told you have to learn everything together. Fatima Aflap, your question now you asked earlier. I will be giving shortcut tips to find the variations, like to write quick answers rather than following reasons behind it. It's not a good approach, but I will be not a good approach in chemistry. If you don't have reasons, it's going to be hard to continue because හිතන්නකෝ මෙහෙම කියලා one strength variation for FF, CLCL, BR, and I තියෙනවානේ height in F2, CL2, BR2 කොහොම තියෙනවානේ. This is the bond length variation. Bond length එක වැඩි වෙනවා මේ පැත්තට. Bond length is increasing from this side to that side. But people, the bond strength variation, again, the strength of the bond is not to this side. You might be wondering now it should be to this side නේ. ඇයි ඒ? You might be wondering it should be like this, the bond strength. The strength of the bond. This is the length of the bond. This is the strength of the bond, because the shorter the bond is, the stronger it is. Like you can understand, people, you can't break this clip in half. The clip එක half කඩන්න අමාරුයි, but when it's like longer like this, you can break it. You understand? When it's longer, you can break it. But that's not true. The fluorine is lowest here. Fluorine is the lowest here. CL is the largest. Bond strength is largest in CL, and then BR, and then FF. And then comes iodine thing. Make it a shortcut now, people. No, there are no shortcuts for this. There are shortcuts, for example, now electronegativity of the highest elements. I told students phone calls variation. I call them it as phone calls. Why do you call it phone calls? It's like FONCLS. Fluorine is the most electronegative, then oxygen, then nitrogen, then chlorine, then sulfur. Phone calls. It's like phone and CLS calls. But mainly you should know the reasons behind everything if you want to get an A for chemistry. You will have to understand the reasons behind everything. Shortcuts and tricks, they are there, no issues. Okay, guys, did you do the question? Are you doing right now? Okay, keep doing. අපි කරගෙන යන්කෝ ඉස්සරහට. Let's do and see. Quantum numbers අද ඉවරයිනේ. මේ part එකම ඉවරයිනේ. This whole part is over නේ. Yes, yeah, in structured essay questions and all, and MCQs also you can use. Yes. Yes, in question 1, Roman number 1 and Roman number 2 both. මේ ඔක්කොම homework කරන්න ඕනේ හරිද? You have to do it as a homework. I'll be doing the first few questions. So these homeworks will have deadlines. And all the homework in all the tunes will be discussed fully. Either through recordings, either through the live class, all questions, everything will be discussed. So please do them. I'm trying my best to help you. If you don't help yourself, then it's going to be a mess. If you don't help yourself, it's going to be a mess. Hari, people, an atomic orbital is described by 3 quantum numbers n, l, and m sub l. We know that. Write the relevant quantum numbers and the atomic orbitals in the boxes given below. Look, n, l, m sub l, and the atomic orbital. Hari? People, they have given this one as +1 and they have given this one as 2p. So how do you write the n value? The n value you can take from this 2. Then 2p ne, 2p කියද්දි n is 2 and p කියන්නේ මොකක්ද? l is equal to 1. 0 කියන්නේ s ne, p කියන්නේ 1. There you go. Then second one, they have given this one as 4, 2, minus 2. They're asking us to write the atomic orbital. Now 4, what is this? D, right? Easy. 4d. 4d. Okay. The next one, third one. They have given only this one as 3s. That means what? N equals 3, L is 0. And m sub l, there's only one value. When L is 0, it's like it's only one value. It's 0. The last one, fourth one, this is 3, this is -1, this is 3d. Then what is this? 3d ne? 3d means what? L is equal to 2. L is equal to 2. Free marks, right? Free marks. Today you join the class. Within like 2 hours, you learn this and now you can answer these kind of questions. That's what you call like learning. You have to keep this in your head, okay? You can't forget these things. Today you learned. If you forget it, then it's useless. Like gone wasted. Aparadi. So keep in your mind these things. Second Roman number, out of the valence electrons of element A, only one has a set of quantum numbers 3, 1, -1, and +½ for L equals 1. Let's see. My idea is keep 2 books mainly. For questions, keep a separate book. For short notes, buy a book. Again, there are art books are හොඳයි. Art books are good, and also like science books කියලා තියෙන්නේ. Like මේ both sides you have empty A4 sheets මෙහෙම. That kind of book is good for short notes. Honey? Or else you can use A4 sheets and put it inside a file. I did like that for chemistry. For bio, I took a book actually, science book. කියලා එකක් ගත්තා. So it's easier for me. For questions, you can have a separate book. In our class, I'm going to give a lot of questions. So you should be able to do them. ඒවා කරන්න වෙනම book එකක් තියාගන්න. And also track everything now. The midnight accelerators කියයි, අරග කියයි, මේක like many things will come in future and there will be a lot of work to do. So if like you have to manage your stuff. Like A levels කියන්නේ people, it's not only just going and writing a paper. This is a big exam. In England, you have SAT exams, right? ඒ වගේ තමයි in Sri Lanka, you have this GCSE A level exam and it's a big exam. This is like make a paper එකක් විතරක් නෙමෙයි. Inside this A levels, there are many things. Emotional balancing. Number one, if the parents are like some parents, අර මේ පොඩ්ඩක් ඇතන් like they're scolding නේ. Like if the student gets 99, the parents are asking, where is that remaining one? අන්න එහෙම කට්ටියක් ඉන්නවා. නැත්තේ නෑ, like there are people like that. The second one may like emotional balancing, not only that. හරිද? වෙන වෙන සීන් තියෙන කට්ටිය ඉන්නවනේ. හරිද? ඒව balance කරන කට්ටිය ඉන්නවා. Like that's also emotional balancing. We are humans නේ. We are humans. Something like that could happen, anything like, but just know that they won't exist forever. හරිද? Trust me, whatever the kind of bond you have right now, within the next 5 years, it will be gone. Trust me, it will be gone. Like majority, 99%, that will happen. Maybe 1%, 2%, rarely it will stay. Ekahinda, just if you really want to work this time, 8 months you have, give your maximum focus. Anit sielu de atarina, like just drop everything else and give your maximum focus to this. And if you still say that I am giving maximum focus and you're playing games and like using Instagram, using Facebook and hanging out with friends, and you're not actually working. That's a lie then. You're lying to yourself and you're lying to me. You have to work on yourself and you have to like act accordingly. You have to tell and act accordingly. හරිද? මේ අර වගේ පිස්සු වැඩ තියාගන්න එපා during this 8 months. This is the life change. This is a life changing 8 months, people. If you do this now, your future is like your salary. Your future salary. This is how you treat your parents. This is your future job. Hare, no matter what you are, like you can be a girl, you can be a boy, whatever. Hare, even if you're a girl, you can't be depending on your husband's money in future. Like that's very like you should be doing your own thing. Again, you should be stable. You should like earn money. Like you should have a proper job. You should have proper status in your life. That's when like you shine. Doctor or scientist or whatever it is. Don't care. Engineer or lawyers. Lawyers. Engineers or doctors or whatever the surrounding jobs. Just, try to reach your maximum. Make a කරගන්න කොහොම හරි. මේක මම last time මේ කියන්නේ. There is no chance. හරිද? 8 months කියන්නේ it's a very tough period. මේක හට්ට කන්න people. 90 hours per week. 13 hours per day. හරිද? මං කිව්වනේ, I told you in the special meeting, like if you manage to study that 13 hours, you can even watch a movie 2 hours. But you should work in that 13 hours. That's what's called balancing. In university, there is like nothing like studying always. There is nothing like that. You should be balancing in the university. And ඒකට යන්න නම් you have to do that in this life also. Like the problem with bonds with other people, you know what I'm telling, right? ඒ වගේ අවුල තියෙන්නේ, the moment the other person changes, your emotional state changes. And then that's going to affect your work. That's why I say, please get rid of anything that you have right now for the next 8 months. That's why I say that. So please keep that in your mind. Because if you don't do this now, you will have to do it again. You will have to do it again and again and again and again. For 3 times you can do this. A levels you can do 3 times. If you skip, you can do it at least 10 times. Skip kar යන්න ඉතින්. හරි. ඊට පස්සේ when you are like 30 years old and you have a kid, you will get your A level results and your kid will be like, mom's A level results out. හරි. You can do it like that also, but you can just finish it this time and make your future nice. හරි. මෙතන ඉන්න second share කට්ටිය ඉන්නවා, third share කට්ටිය ඉන්නවා, some people. My thing is, give your maximum for these 8 months and focus and work. That's what I'm going to tell you, and you should do it. හරිද? You should do it. There is no excuses, nothing. You should do it. Out of the valence electrons of element A, only one has set of quantum numbers 3, 1, -1, and plus or minus half. Identify the element A. Now, people, 3, 1, minus half, plus half. So there is only one electron loop which has the quantum numbers like this. So n equals 3 කියන්නේ මොකද්ද? Third period. නැත්නම් third energy level. In the periodic table, you have the first, second, and third period නේ. So it belongs to this period. Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. From those, one of them. And next one, they have given it as L equals 1. L equals 1 කියන්නේ මොකද්ද? It's a P subshell. So it's in the P block. ඒකෙන් අපිට ගන්න පුළුවන් it's in the P block. Now you have narrowed your view into aluminum, silicon, phosphorus, sulfur, chlorine, argon. Then the next one, -1. -1 කොහොමද ගන්න? How are you going to take now? The filling order. කොහොමද fill කරන්නේ? -1, 0, and +1. How are you going to fill? First you fill into this. හරිද? And you fill into this, 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 and you fill into this. That's the filling order. So according to this people, they have given for L equals 1, 3, and 1, it's a P subshell, and the M sub L value is -1. They have also told out of the valence electrons for element A, only one has the set of quantum numbers. A කියන්නේ it can't be this second electron. It can be only one electron. A කියන්නේ it's like this. It has only one electron like this. මෙහෙම. හරි? So it is aluminium, right? It is aluminium. Identify the element A, it's aluminium. So how do you take it as aluminium? Aluminium belongs to this one. M sub L -1, that's the first electron you fill into the P sub energy level. Did you understand this one? Therefore, how did I take this and how to think through it? Did you understand? Yes. Very good. Second one, write the ground state electronic configuration for the element A. People, for the element A, the electronic configuration you can write now aluminium 1s2, 2s2, 2p6, 3s2, 3p1. This is the ground state electronic configuration. Then third one, write the condensed electronic configuration for the monopositive ion. Make a monopositive again. You remove this electron. You remove the 3p1 electron. You remove the 3p1 electron and then only you write it. So the condensed one you have to like until here. Metica ඔක්කොම වෙනකොට you can write it as what? Neon. Neon and then 3s2. You cut off this electron. This electron is removed because it's a monopositive cation. You remove one electron. So this is the answer. Okay. Next one. Second one now. Try to do the second one. You have to write everything there. Identify the subshells along with the azimuthal quantum number L and magnetic quantum numbers M sub L for the energy level with principal quantum number n equals 3 in an atom. Again, for n equals 3, what are the possible subshells and what is the azimuthal quantum number of it? And what are the magnetic quantum numbers that are possible? And also the maximum number of electrons that you can fill into each. Do it. Using your knowledge, it's okay to get it wrong. It's okay, people. It's okay to make mistakes. You can make mistakes right now. Don't make mistakes in the A-level paper. That's it. You can make mistakes in term test papers. You can make mistakes in anywhere, but Don't make that mistake again in the A-level paper. That's all. Correct your mistakes and move forward. Yes, break I'll give. People may like I forgot. You can have a break right now. Now it's 9:07. I'll give you a 20 minutes break. Come back at 9:27. Come back at 9:27. I'll be starting at 9:27. Hari? May it's your decision to leave the meeting and go right now. I won't tell anything, but it'll affect you later. Watching recording Q&A procrastination epa කියලා. It's your decision to like you can press the leave button and go. It's easy to cut an online class. Just press on the leave button and tell your mother that the class is over. That's all. Easy. You can easily cut the class and go. That's all. But you should be thinking like an adult right now, and you should take your own responsibility to your head. Otherwise, you won't be able to do this. So 9:27, I'll start. Have a short break. Maybe you can take your dinner if you didn't have it. 20 minutes enough, ne? I eat in 10 minutes, bro. Like I eat in 10 minutes. Seriously, 10 minutes only. ඒ කියන්නේ අර මම පොඩ්ඩයි ගන්නෙ ගොඩක් කන්නේ. Okay. Remind me to start the recording, okay? Okay. The people who are watching recording, I didn't teach any theory part. I just told to take the question book and write this topic. Write quantum numbers for outermost electron and lastly fill electron in the following atoms. The first one I told sodium and then I erased it. So, and then scandium's electronic configuration you write, and then the outermost electron will be the 4s2 electron, again, the lastly filled electron here. So n equal 4, L equals 0, m sub is 0, and m sub is plus or minus half. The lastly filled electron is this one, the 3d1 electron. There you go, the quantum numbers for that. And then third one is chromium. For chromium, you write it and you get 3d5 4s1. The outermost electron will be 4s1 electron. There you go. And the lastly filled electron will be 3d5 electron. So the recordings you said we should watch them before which class? Next Monday. Yes, within this week you have to complete watching them. So does the valence electrons means all the electrons in the element? No. Valence electrons කියන්නේ now let's say sodium. Sodium වල valence electrons කියන්නේ the outermost shell. This outermost shell එක තියෙන්නේ. Valence shell කියන්නේ this shell, the outermost shell, which interacts with the other elements which react. Reacting electrons, you call it valence electrons, the outermost shell electrons. So every electron in this outermost shell, you call that the valence electrons. Okay? Hare. Then that's chromium. Now, the last example I'll write here, manganese. Manganese is copper. Copper, let's write. Copper is 29. Copper is 29. Copper is 29. Would it be enough if I do past papers only from 2019? No, it's not enough. No. 2019. Ayyo, only 5 years ni. Huh? 6 years. So 25 term. 6 years, not enough. At least like 2014 until like from 2016 enough. 16, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. That's right for copper, right? One is two is two P6, three is three P6, 3D10, 4 is 1. Hari? Is the corrected configuration I wrote? Hari? I told like 3D9, 4 is 2, I have to take one electron towards the 3D. That is that. Yes. Past paper practice not enough in I can only not again past papers without it's like not enough. How is it? Because new questions are being asked sometimes. Again, mostly past papers are repeated, but sometimes new questions are being asked, and like past papers not enough. Like there's only like if you take 6 past papers, 5 into 6, 30, 300 MCQs. How is the muddy thing? Like it's not enough. Uh, so outermost is the same thing. හරි the same thing බලන්න. මෙයාගේ same thing නේ එන්නේ. N equals 4, L equals 0, M sub L is equal to 0, and M sub S is plus or minus half. Now you might be wondering, what did Pauli tell? Pauli told, what did he tell? He told that no two electrons can have the same set of 4 quantum numbers. Then you're writing it like that, ne? Same, ne? People, don't you remember? I told that same electron, again, two electrons of the same atom. This is copper. This is copper, people. That is chromium. That's different atom. Two atoms can have same quantum. Now that is fine. How is it? A parallel universe can have a candy which is in the same location. Now this is our universe. There could be a parallel universe. This is outermost. And then lastly filled people, n equals this 3D thing, n equals 3, L equals 2, M sub L is equal to plus 2, and this one M sub S is plus or minus half. Now this one may 3D10 people, 3D10 here, the D is fully filled. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. It's this electron. People, if this is plus half, the other one should be minus half. So we can't exactly tell which one is which. We can't tell exactly which one is which. What other papers would you recommend to write? School papers or any other, including your papers, right? Paper class. I highly recommend you to join for the paper class also, because people, then now this week you have the MCQ paper, 40 MCQs. Mama papers I have created such that it is parallel with your term tests. හරි ඒ කියන්නේ schools and everything, like I have given until inorganic. මම revision එකේ කරන ටික විතරක් නෙමෙයි paper එකට දාලා දෙන්නේ. Like until the school, like how school follows, I have put questions. හරිද? So until inorganic you have the paper class. Paper class එක inorganic from inorganic until inorganic you have the papers. එතකොට මේ every week, now this week MCQ paper, 40 MCQs. Next week you have the essay paper. In the essay paper you will get the first structured essay question. ඒ කියන්නේ a general chemistry question, and then you get the inorganic structured essay question, and then you get the physical chemistry structured essay question, and then the fourth one you don't get. ඒක තාම කරලා නැති හින්දා organic and all not fully completed. I haven't given. Then I have given the fifth essay question, which is physical chemistry essay question, and also I have given the ninth essay question. Again, inorganic essay question I have given ඔන්න ඔය ටික තමයි this week and next week we have for the paper class prep papers. So if you're writing school papers, of course you can write school papers, no issues, but don't forget to have marking schemes of what you're writing. Without marking schemes, doing papers are useless, completely useless, because you don't know which one is correct, even you're just putting your answers and going. If you want, you can do school papers, but I think it's not needed because we are covering everything here. Like everything is given to you. Okatiki papers, hadane from school papers, Moratoa papers, Thondamanar papers, like FWC papers, and like all the papers combined. ඒවා තමයි හදන්නේ. හරිද? එතකොට the same papers like එකම දේ තමයි තියෙන්නේ. Like එකම දේ තියෙන්නේ. The same question patterns and everything. හරිද? I don't think it is necessary to do separate papers even after coming to the paper class. Paper class එකට ඇවිල්ලා වෙන papers කරන්න මම නම් හිතන්නේ අවශ්‍ය වෙන්නේ නැහැ people. No need. Like every month you're completing 2 papers actually. Then until now, I told you like shadow papers, until shadow papers, you will be doing 1 week MCQ, 1 week essay, 1 week MCQ, 1 week essay. In shadow papers, you will write a full paper in the same day. With a break in middle, full paper in the same day with a break in middle. That's how you write my shadow papers and the ATP papers. So I highly recommend you to come to the paper class also together with the revision. It's not because I need to take 5,500. It's not like that people. Like I never I never beg for money and මම අදත් එක ළමෙක්ට free දුන්නා. හරි මම ළමයි 3 දෙනෙක් like 3 students I have given free in this class. එතකොට I don't tell it like that, but I recommend you to come to the paper class also if you are coming for the revision. හරිද? මේ එනවා නම් අර විදිහට එන්න. Because it's easier for you and I recommend like every week you're getting a Lewis structure. Just imagine that. Every week, every once or 2 week. හරි once or 2 week you get a Lewis structure. Like ඒකට marking scheme එක you will get a marking scheme, also a discussion, and also your marks will be uploaded to the website and like a marking curve where coming up. Like oh my god, you will get a performance curve. You get a performance curve in your website. ඒ ඔක්කොම වෙනවා. So it's a completely like very ordered process and very neat process that's going to happen. How did you get +2 for magnetic quantum number? Why? +2 tamai. It's the last ne? It's -2, -1, 0, +1 and +2. So the last electron is, this one. Okay. So that is belonging to M sub L +2 here. Do you understand? Right. Cool. People, the rest of the MC now, here in the workbook, you will get this book actually. In this, you have quantum numbers plus Aufbau rule and Hund rule. In that, do all the 15 questions. Do all the 15 questions here. May ඔක්කොම කරන්න as homework. So here, the first homework I give you. Complete the quantum numbers questions. Complete the quantum numbers questions. Make a deadline people. මට midnight accelerate එක දාන්න time එකක් හොයාගන්න ඕනේ. Wednesday night, no, Thursday, Friday. Friday is good, right? On a Friday we have the 26th. Saturday or Sunday. Do it before Saturday. Will you deadline Saturday? Deadline Saturday. On Saturday, people, I'll be sending the MC the PDF for that night's accelerator class. I'll send a small PDF revising the parts which we did today and also some new question patterns and everything. I'm going to give in that. The class will be around 1 hour. Loku class, and it's not a big class, just 1 hour small class, just to revise the stuff for you and for a small enjoyment, talk and stuff. Eka 1 hour class, a small class, it's free for everyone. Anyone can come. Let's discuss chemistry in that class mainly. So out of clockwise and anti-clockwise, which one is positive and which one is negative? එහෙම එකක් නෑ. ඉතින් like plus you can consider clockwise, negative you can consider anti-clockwise. It's like not a rule. එහෙම rule එකක් නෑ. Okay, this is the homework for you. And people, I want to teach another variation for you. Since we have time. Turn to you don't have the tute. Ned. I have to do something which doesn't require the tute. Turn to photoelectric effect. Turn to photoelectric effect in the PDF which you have got. Hari, people, did you understand quantum numbers as a whole? Every one of you in the meeting. තේරුණා නේද? Are you like fully okay with quantum numbers part? Hari? No more questions from today onwards. Again, no more questions. Like no more questions in theory. Like you can't be there learning quantum numbers again. That's what I mean. Hari? From today onwards, it should be there inside yourself, this quantum number. This is one MCQ. Trust me. Every year there's a question. Every year there's an MCQ from this. Every year, people. Every year. And also in the structure dissection also you have. Okay, everyone told yes. Which is nice. Very clear. Okay. Okay, almost all of you told yes. Understood. Okay. Okay, now let's go for this photoelectric effect thing. Photoelectric effect. What do you think Albert Einstein won the Nobel Prize? For what? Anyone who knows? Albert Einstein won the Nobel Prize for what? Einstein won the Nobel Prize for what? Anyone? No? Not for relativity. No, not for relativity. Photoelectric effect. Albert Einstein found the photoelectric effect. That effect, he only found it. This thing was discovered by Albert Einstein. So it's an honor to learn something which he found in our syllabus. Isn't it? It's an honor to learn something which he found. Hari? Photoelectric effect. Right. Look, people, under photoelectric effect you have Max Planck proposed that energy is quantized. Again, energy is quantized. Okay, what does that mean? You shine a torch. Do you have a torch near you? I don't have a torch near me. You shine a torch. People, in the torch, light is going to move out of it. People, Max Planck told that inside this beam of light, it contains particles. Until that, people, other scientists have told that it's waves. Energy is just waves. The energy is waves, Lou. But Max Planck told energy is quantized. Quantized, there is something called small particles, like energy packets. There's something called energy packets. Small particles. Again, these are quantized. Quantized. You found this word first in O-level science book. You found this word first in the O-level science book. If you can remember, there was a unit. Quantization of something I can remember. Quantized means you can break into small particles. Again, single particles. That's what Max Planck did. So he told energy is quantized and he gave an equation for it to calculate the energy. To calculate the energy of this one packet, the energy packet, he gave one equation. Yes, quantification, yes. To calculate energy of this one energy packet, he told if you apply this equation E is equal to HF, you can calculate the energy of that photon. Sorry, I told the word photon. This energy packet, if it's light, then we call it as a photon. How do you call it as a photon? Now you might wonder, oh yeah, now frequency means waves, ne? Isn't it? Frequency is waves, ne? Then why this Max Planck tell frequency for a particle? Like, is he mad or something? No, people, these are light, ne? Light has particles moving in a wave-like nature. එහෙම තමයි යන්නේ. That's what he told. So these photons have a specific frequency. So people, do you know blue color, red color, green color, orange color, like yellow color? These colors are created due to different frequencies. Actually, people, there are no colors. That's the truth. People, this board, you see it as white color. This, like the wall, you see it as gray color. You see this bottle as red color. Why? That is how you see the world. It's happening inside your eyes, people. If you know bio, like there are receptors inside your eye. There are receptors inside your eye which catch these wavelengths and they will interpret a color to you. Like the brain will say, it's blue color. But actually, it's not true. They are different, what do you call? Different objects which emit certain radiation. Right? Yes. Pros and cons in eyes. They will emit certain radiation and your brain will be processing it to produce, like, tell you, bro, this is blue color, this is red color, this is orange color. If your brain can't take it, it's like beyond violet, you call it ultraviolet. Ultraviolet, your brain can't see it, like there's no receptors to catch that. If it's below the red, infrared, you can't see infrared. But there are some animals who can see infrared also, who can see ultraviolet also. Bees and all, they see ultraviolet and infrared light. Okay, people. Now E is equal to HF. When you apply this equation, you can calculate the energy. For blue light, it has a different frequency. For red light, it has a different frequency. For orange light, it has a different frequency. Likewise, different colors have different frequencies. You can calculate the energy of this photon by applying this equation. You have to know the frequency of this. And also you have to know the value of H. What is H? It's a constant. H is a constant. What do you call that? The Planck's constant. H is known as the Planck's constant, and the value for that 6.626 into 10 to the power minus 34 joules second. Hurry, 10 to the power minus 4 joules second. The best way to remember these things is put it as your phone's password. Hurry. Again, the value of pi, value of Planck's constant, the value of gravitational constant. Likewise, like some people do that for passwords and all, they use it. Sometimes they put the value of Planck's constant divided by gravitational constant. The answer only their password. I also had this, something like this back then. Oh, like this is the Planck's constant value. You don't have to memorize it, people. They give it in the paper. Hurry. They give it in the paper. Hurry. People, now in the tute. Read that part. Planck gave the name quantum, meaning a fixed amount to the smallest quantity of energy that can be emitted or absorbed as electromagnetic radiation. එතකොට මේකට අපි කියනවා එක ඉන්නේ මේ මෙයා කිව්වේ මේකට quantum කියලා. හරිද? මේකට quantum කියලා තමයි කිව්වේ. What is it? A quantum. Quanta an energy packet. Had many quantums, you call it on quanta energy packet, meaning it's a fixed amount to the smallest unit of energy that can be emitted or absorbed as electromagnetic radiation. He proposed that energy E of a single quantum is equal to constant time the frequency of the radiation. Equals a constant time of a single quantum equals. නෑ ඒක වැරදි. ඒ කියන්නේ පිස්සුවක් එතන තියෙන්නේ. He proposed that energy E of a single quantum is proportional to the frequency. Is proportional to the frequency. Correct it. හරිද? Equals a constant විකාරයක් නැති ඉන්නේ එතන. හරිද? of a single quantum is proportional to the frequency. Therefore, you can write this equation E is equal to HF. So this energy is for one photon, isn't it? This is for one photon, right? This is for one photon. If you want to calculate the energy of two photons, what you do? E is equal to HF into 2 photons. Do you understand it? If you want to find the energy of 100 photons, you multiply this by 100. If you want to calculate the energy of, listen, 1 mole of photons, what do you mean 1 mole? What is 1 mole? How much? 6.022 10 to the power 23 amount of photons, you call it 1 mole. So you have to multiply that value, multiply by that value. E is equal to HF into 6.022 10 to the power 23. And that number, you give a specific name to it. What do you call it? Avogadro's constant. Avogadro's number. Avogadro's number, Avogadro's constant. Right. Now, people, in the tute, you have a space there given in the next page. Again, a tute take a when you get the tute. In the next page, here, the space given here, I want you to write this stuff. If you want, you can write it in an A4 sheet or something. Okay. For one photon, E is equal to HF. For one mole of photons, E is equal to HF into L. What is this L, people? This letter L represents the Avogadro's number. Avogadro's number, people, and the unit. Make a unit taker per mole. Per mole. Make a value maker. The value will be 6.022 10 to the power 23 per mole. 6.022 10 to the 23 per mole. That's the value of that. So E is equal to HF into L. Now I can do something like this. So what if they don't give the frequency? Sometimes they give the wavelength. They say there is a photon with this wavelength. Calculate the energy. That's all. What you do? You know this relationship. V is equal to F lambda. V equals F lambda. You know this. People, velocity of light. What is it? 310 to the power 8 meter per second. That is a universal constant. That's a universal constant. In a vacuum, the speed of light is 310 to the power 8 meter per second. And no one can go beyond that speed according to Albert Einstein. You can't go beyond that speed. Trust me, you can't. It's a constant, like any object trying to move at the speed of light. If that person can achieve that, he can, let's say he leaves the earth by a rocket which travels at the speed of light. At the speed of light. So let's say he's 10 years old. He's 10 years old and he has a sibling who is like twin. He has a twin who is also 10 years old. If he roams around here and there for some time and then come back, he will find out that he is still 10 years. This guy is 50 years. There's something like this happening. There's something like this happening. So traveling at the speed of light is considered impossible. But if someone can achieve that, he can stop time. Like time travel and everything. Like you can travel into the future. If you can move at the speed of light. Okay, that's a story I just told. People, this V. Make a C කියලා මන් ලියනවා. What is C then? C කියන්නේ speed of light. C equal F lambda. So I can subject the frequency and write C over lambda. C over lambda. C over lambda. Now what I do, I substitute this one and this one together Instead of the frequency here, I put C over lambda. So E is equal to HCl over lambda. Do not memorize. Do not memorize equations. Please, I beg you, please do not memorize equations. It's the most ridiculous thing you can do here. Just remember this equation E is equal to HF. That's all. Then you can get this one mole of photons. So you get this equation E is equal to HF into L. And the frequency now V equal F lambda, C equal F lambda. Right? And then F you can write C over lambda, and instead of the frequency, you can write C over lambda here. That's it. Write this. එතකොට මේකත් 1 MCQ. මේකත් 1 MCQ. This will also be 1 MCQ in your paper. This will also be 1 mark. So within today, we have completed 2 marks. So even if you start from 0, you have collected 2 marks within just, how much hours? Now it's 10, 3 hours. Okay, people, let's read the dude. One photon can remove one electron if it has energy greater than the threshold energy. What is that? What is threshold energy? People, some guys tell, I have a threshold level. මොකක්ද threshold level එක කියන්නේ? There are limit. අර limit එක පෙන්නම තරහා යන්නේ අර some people like they have a limit they tell. Don't exceed my threshold anger level. හරිද එහෙම කියනවානේ. That means what? It's the maximum amount of time they can bear. And then they hit the other person. That's the threshold value. So when it comes to these theory parts also, that's the threshold something. What is threshold? Threshold energy is the minimum energy required to remove an electron from the metal surface. That means photoelectric effect again, and we have to talk. Until now, we didn't talk about photoelectric effect. We didn't talk. We just told a light beam is moving, and in order to calculate the energy of this photon, only we learned an equation. That's it. That's the only thing we did. To calculate the energy of this photon, we use that equation. That's all we did. But photoelectric effect is something else. Photoelectric effect කියන්නේ in order to remove an electron from a metal surface. That is photoelectric effect. The minimum energy required to do that you call threshold energy. So let's say there is an electron here. Then make a ලස්සන story. There's a nice story behind this. Listen. Consider this metal surface as a parent. Parents කියමුකෝ, these are parents. And these are daughters. These are daughters. එතකොට this photon is a boy. He's a boy who is like, a good boy, let's say. So the boy asks for a daughter. Boy is asking for a daughter. But parents have what you call threshold values. He should drive a BMW definitely. Parents BMW definitely he have to drive. And he should have, let's say, 5 lakhs in his bank account. That's the second requirement. Third requirement, he should be told. He should be told. So these 3 requirements is needed by the parents. If the boy doesn't have that requirement, then he can't take the daughter out. He can't take the daughter. He can't marry that person. what if the photon was like, what if I take another friend and come, that friend and him both, the energy, like the, money combined, he will have 5 lakhs. Him a bad people like that. It's not possible. One, two photons cannot come and remove one electron. And that's like very bad. It's not allowed. That's not happening. Right? The parents won't allow that. So it should be one single photon which is removing one electron. අපි මෙහෙම හිතමුකෝ මූට සල්ලි වැඩි දැන් like he has a lot of money like 5 lakhs නෙමෙයි he drives 3 BMWs and මේ 15 lakhs he has in his bank account and he is very tall like a coconut tree හරිද ඔක්කොම ටික වැඩි දැන් එහෙමයි කියලා like does the parent give 3 daughters to him no that doesn't happen එහෙම නෑ one photon one electron one photon one electron that's it one photon one electron one photon, one electron. That's all. If the photon cannot remove, that's it. You can't remove. The maximum energy, the minimum energy needed to remove an electron from a metal surface, that is known as the threshold energy. So when you get the tute, you have to draw this actually. One photon can remove only one electron. One photon can only remove one electron and threshold energy is the minimum energy required to remove an electron. So make andinone metana like you have to draw it here. At a previous note you have to write it here. Okay. Now people, now take the book. A workbook. Take the workbook. In the workbook, mark these questions. In the workbook, mark these questions. Question number 1. Question number 2. Question number 4. Question number 5. Question number 6. Question number 7. And yeah, that's it. 1, 2, 4, 5, 6, and 7. 1, 2, 4, 5, 6, and 7. Please do them now. Now do it. I'll give you 15 minutes. At 10:30, I'll discuss. Please do this right now. Then do it. Do all. Try to do your best again. Like you try your best to do it. Even if you couldn't do it, fine. Make sure you put units, okay? Lot of students lose marks because they don't use units. In A levels, now you have to use units. Again, for example, if it's a structured equation, how the MCQs now MCQs you have to put the underline the correct answer. That's not like that. But in A levels, when it comes to structured equations and essay equation, let's say you apply to this equation PV equals nRT. Maybe in outside other syllabuses, again, like other countries and all, they don't worry about it much. But our people, we worry about the unit. First of all, when you're substituting, you definitely have to write the unit. For pressure, you write 110 to the power 5 Pascal. Volume 1 into 10 to the power minus 3 cubic meters is equal to, you have to calculate number of moles, and R 8.314 joule per Kelvin per mole. And temperature 300 Kelvin. You have to substitute with units. Very important. Substituting with units. And then you can ignore the units. And then in the final answer, you have to put the units again. In the final answer, you have to put the units again. So this is very important. People writing this equation, you get marks. Writing this substitution with units, you will get marks. And the final answer, you will get marks. And also final answer with units, you will get extra marks. That's how it works. So even if you get the last answer, just apply PV equal nRT and put the last answer, then only you will get 2 marks. That's all. Copy you can copy and take useless. So all other marks are there in the steps, people. Substituting, writing the equation, getting the final answer, getting the unit. Everything is included in your marks. So there's a correct, like when writing the paper also, there's some discipline you have to follow. Hari, do the questions now 1 to 7, 1, 2, 4, 5, 6, 7. Don't do the third one, okay? Don't do the third one. Oops. Don't do the third one. And don't do the eighth one. එතකොට මේ if you are writing papers physically at Faraday, you will get a MCQ sheet. හරිද? You will get your paper. You will be invigilated and there will be intervals and everything. It's just like the A-level paper. A-level paper එක වගේම I'm giving you the conditions just like that. So if you want, you can come and write in Faraday, or else you can stay at home and do it online. No issues. Anyway, it's possible. But make sure you don't copy at home and stuff, like just fooling yourself. You need to learn how to use logbook. හරිද? You will understand now when doing questions. Sometimes it will take longer time to simplify just by normal method. You are not allowed to use calculators in our A levels. Like, I don't know why. Commerce people can use, IT people can use, not the chemistry and physics, maths, bio. You don't need a calculator. You can't use calculators for them. Like the calculator was invented for maths people. Maths වලට ලියන්න දෙන්නෙත් නෑනේ. Like that should be changed, right? I mean, like if they allowed calculators, the papers will be hard. Papers will be harder than what they are today because it will take time to simplify. So they are making the papers like it should be balanced. So the paper will be easier if you do the calculations like using a logbook or something. So if a calculator was allowed, the paper will be more hard. So I don't know whether it's a good thing or bad thing to tell that calculators are not used. In universities, you can use. Please stop using calculator. Sorry, again, if you're using at home, please don't use because in the A-level paper, you can't negotiate and take a calculator. You can't do it. So you have to learn how to do it, like your calculations and all you have to develop. May to do it faster, simplify faster in your brain. When you do a lot of questions, you will understand that. Okay, I'll do the first question now. Shall I discuss the first one? Or else should I stay until 10:30? Tell me, people. Okay. Okay. Some people told to discuss, so I'll discuss. First one, green light of wavelength 4.42 10 to the power minus 7 meters is observed in the emission spectrum of hydrogen. The energy of one photon of this green light, easy question. Now you have to calculate the energy of that photon. Wavelength of 4.42 10 to the power minus 1 is observed in the emission spectrum of hydrogen. The energy of one photon, so just have to calculate this, is equal to hf, but they have not given the frequency, they have given the wavelength. Wavelength can hc over lambda you have to apply. So h is going to be 6.626 10 to the power minus 34 joules second multiplied by speed of light 3 10 to the power 8 meter per second divided by lambda 4.42 into 10 to the power minus 7 meters. Now the thing is, people, look, this is an MCQ. This is an MCQ. You can take approximations here. Look what I'm going to do now. I hope you went on simplifying everything, but no need. Look, now this is 4.42. I can assume it to be 4.4. And this one I can assume it to be 6.6, like approximately same. Now what you can do? You can divide by 11, right? Then it's going to be 6 and here 4. You understood? Now it's easy. Now it's easy. Now 3 into 6, 18. 18 divided by 4 multiplied by, now this 7 minus 7 comes on top and this one becomes 15. 15 and 34, it simplifies and becomes 10 to the power minus 19 joules. So it's going to be 4.2 remaining 5. 4 into 4, 16, 2 remaining 5. Yes, 4.5 10 to the power minus 19 joules. They are asking it in kilojoules. Look, kilojoules. Kilojoules කියන්නේ in order to convert joules to kilojoules මොකද කරන්නේ? මෙහෙමයි people. Now this is the thing. Unit conversions, I am covering that in chemical calculations part separately. Again, fully, like unit conversions, I'm going to teach you, which will be useful for all three subjects. In bio also, water potential, megapascal, something like that. Water potential you did. In bio you have unit conversions also you need there, right? Whatever. However, unit conversions will be done in the chemical calculations part. And then you will understand this more further. For now, I'll just tell you what to do here. Joules to kilojoules, you multiply by 10 to the power minus 3. Again, you divide by 1000. Just converting grams to kilograms. Okay, joules to kilojoules, grams to kilograms, meters to kilometers. Same thing. So you multiply by 10 to the power 3. 10 to the power minus 3, sorry, kilojoules. So 19 and 3, you can add them together to get 4.5 10 to the power minus 22 kilojoules. There you go. 4.42 10 to the power minus 22 kilojoules. So that's going to be answer number 4. First one, answer number 4. First one, answer number 4. Okay. Take a screenshot of this if you didn't write this. Look at the second question. Look at the second question. People who did this question, raise your hand. Then බලන්න people, 21 people in the meeting. Survival of the fittest. හරිද? If you are there until now, you have a big self-confidence in yourself. හරි? දැන් වෙනකන් අල්ලන් ඉන්නවා කියන්නේ, you have a big self-confidence inside you. So be proud of that. හරි? Okay, let's do it then. Lamp produces 6 joules of energy per second in the blue region of the visible light. Blue region, 470 nanometers. Hi? Of the visible light. How long should the lamp be lit to generate 110 to the power 20 photons? Okay, lamp produces 6 joules of energy per second. Okay, then now look, this is what you have to do. Think. Use the brain. Using the brain is the ultimate gift that you can that God has given you in order to do A levels. Think. Don't be bio students. Don't be bio students who memorize stuff only. Use the brain to think during chemistry. Look, now people, lamp produces 6 joules in 1 second. 6 joules in 1 second. So, people, let's see how much energy how much time should it be lit? I mean, should it be kept such that it produces 110 to the power 20 amount of photons? How are you going to calculate that? Okay, first of all, let's calculate the number of photons emitted in 1 second. Number of photons in 1 second. How are you going to calculate that? How are you going to calculate the number of photons in 1 second? Think. How are you going to calculate number of photons in 1 second? I'm telling you one way to approach this question as a beginner. Number of photons in 1 second. What you're going to do? What you're going to do? You apply E is equal to HF. This is 1 photon. For how many photons? Number of photons emitted in 1 second, I'll tell equal to X. So I'm calculating X. Hurry. E is equal to HF into X. So this energy, people, this is in 1 second. I'm specifying 1 second. So this is the energy. 6 joules in 1 second. Now H value 6.6 into 10 to the power minus 34. Frequency, people. Now frequency, they have not given, they have given the wavelength. So I'll write Hc over lambda thing. And this is 3 10 to the power 8 multiplied by x divided by lambda 470. Nanometers. Now nano can 10 to the power minus 9. Don't worry, in chemical calculations we'll cover this. 10 to the power minus 9 will be the amount of meters. Meters well in Tama you have to substitute. You have to substitute in meters. Why are you substituting in meters? Why are you substituting in meters? Because the speed of light we are putting in meter per second. So when you divide by meters, you can cancel the m and m. You can cancel the m and m there. So there you go. And this the Planck's constant unit is joules second. Make a look you can't see. 6 joules is equal to 6.6 10 to the power minus 34 joules second multiplied by 3 10 to the power 8 meter per second multiplied by x divided by lambda. Lambda is 470 10 to the power minus 9 meters. There you go. Now you can see meters and meters cancel off, per second and second cancel off, joules and joules cancel off. No unit will remain. That's true anything. You're calculating the number of photons. So number of photons doesn't have a unit. Right. Then you simplify this. X is equal to 6 into 470 divided by 6.6 into 3. 3 times 2, 2 times 3.3. So that's going to be 470 divided by 3.3. 470 divided by 3.3. Then these things will simplify. Make then this will be 10 to the power 17. 10 to the power 17 and it will be 10 to the power minus 17 and it goes to the other side. 10 to the power plus 17. The Meva simplification. This is not chemistry. This is simplification. will be the amount of photons. Now this will be the amount of photons emitted in 1 second. 1 second, this much amount of photons emitted. How much time should the lamp be lit in order to generate the told amount? 110 to the power 20 photons. Then මෙතන කීයද එන්නේ? 4.7 divided by 3.3 කීයක් වගේද? 4700 divided by 33. 1.10යි 7යි 3යි 4යි. I will use the calculator because I am the teacher. හරිද? I'm going to use the calculator because I'm the teacher. I have done A levels, so you guys can't use calculators. හරි? 3.3 470 divided by 3.3. That is 142.42. 142.42 into 10 to the power 17. You can write it as 1.4 10 to the power 19. 1.4 10 to the power 19. So people, they have told how much time should it be lit in order to generate this much amount of photons. ඒ කියන්නේ මෙහෙමයි. One toffee is this much. How much toffees will it be for 100 rupees? එච්චරයි. ඒ කියන්නේ මෙහෙමයි. One toffee is 5 rupees. One toffee is 5 rupees. හරිද? One toffee is 5 rupees. How much toffees can you buy for 100 rupees? That's all. How much toffees can you buy for 100 rupees? It's like, this is the amount for, like, in 1 second. How much seconds are there in 110 to the power 20? So you, like, මෙතන වුණත් you divide 100 by 5 නේ. And you get 20. You get 20. Here, you divide the 110 to the power 20 by 1.4 10 to the power 19. 1.4 10 to the power 19. So when you simplify this, you will get an answer. If my calculation is correct, everything is correct. 1.4, 0.71, and then you multiply by 10, it's going to be 7.1 seconds. That's answer number 2. Answer number 2. So this is the beginner's method of doing it. I just told you step by step. You calculate the amount of energy liberated in 1 second, and you look at the question and they'll say the time taken to liberate 110 to the power 20 amount of photons, and then you divide by this 1.4 10 to the power 19 amount and you get 7.15. I hope you understood this. Did you understand, people? Yeah, product that like this is the first time you're like trying questions if you're a beginner here, so it's fine. So drop me a message. Did you understand this? Talk. Nidida, people are sleeping now, right? Huh. Okay. Cool. Understood. Hiba, you are 2027, right? No? Hiba Rosan, is that your name? No? There was a student, Hiba Rosan. You're 2026 or 7? Hey, 2027, 2026, ne? In 2027 also there was one student. Okay, people. Now the rest of the questions, 4, 5, 6, 7, you can do it as homework. I want you to get the question practice out of this. I did 2 questions for you. So using that logic and everything, you can try out the remaining questions. Just use some small logic here. Try it on your own. Try it on your own. I'll put a discussion for these questions. Don't do the de Broglie equation questions. Sorry, don't do the de Broglie equation questions. You are going to complete the de Broglie part in the next day because you need some brain power to understand that. And this is not a good time to do that part. Okay, people, with that, the first class of 2026 revision finishes like this. I want you to drop a message in me in WhatsApp telling like how was the class and did you learn anything new, like, how was the class conducted and everything. Just put some comments regarding the class. If something was bad, then tell it. If something was good, then tell it. Everything tell it. I will anonymously put your what you call comment in the group. Then I won't put your name or anything. Just anonymously, I'll put it in the group. So you can drop me a comment regarding the class. Hari, from now onwards, I will allow you to make payments to the class. Some people have already made payments. Now you can make payments to the class if you want to join and continue the class because the next class will not be free, unfortunately. The Lewis structures part, I can provide it for free. The recordings, but chemical calculations and everything, the remaining periodic variations and question discussions and everything will not be free. So what will be free? The midnight accelerators will be free for everyone, and also some seminars I'll be doing in organic and then electrochemistry first class, and like some parts I'll be doing freely for everyone where everyone can come and learn freely. But this time we can like the next class is on what I call Friday. Friday night we have the class, and periodic variations will be continued. Not Lewis Master Etude because Lewis Master Etude we have to do next week after you complete those two recordings. Hari, now you have three homeworks, people. First one you have to do the quantum numbers questions. There are 15 questions. Out of them we discussed one of them, right? The rest of the 14 questions you have to do, and then photoelectric effect questions you have to do, and kinematica 4, 5, 6, 7. And also, people, you have to watch those two recordings. So there are three works to do. Please balance yourself. Hurry. The next class will be on Friday night. So see you on Friday night. Please make payments quickly because I will be couriering the tudes soon as possible. Wednesday night, I'm going to courier. So yeah, thank you for joining. See you again in the Friday's class. Okay, you can leave the meeting. Good night. Okay. Good night.